Hello everyone, welcome to this brand new drone programming with Python course. Have you ever wanted to build an application that can control a drone using Python, artificial intelligence and your body movements? If yes, then you are in the right place. Before we fly a real drone, it is extremely important to practice and learn in a simulation environment. But the question is why? Because real drones are expensive and even a small programming mistake can cause a crash, damage the drone, or create safety risk. A simulator allows us to experiment freely, make mistakes, test our algorithm, and improve our programming skill without worrying about hardware damage or battery life. In this course, we will use PySimverse Simulator to build and test our drone application before applying them in real world. This is the same approach used by many robotic engineers and drone developers during development and testing. Although this course we will combine several powerful Python technologies, including OpenCV for computer vision, MediaByte Task API for real-time AI detection, hand gesture recognition, body pose tracking, keyboard control, and RC commands. By the end of this course, you will know how to create intelligent drone control system using nothing but Python. Now, let's take a quick look what we will learn. First, we will start with the basic of drone movement. You will understand how a drone moves in 3-dimensional space and learn the concept behind continuous flight with RC control command. Next, we will learn how to control drone using the keyboard. We will be able to move the drone forward, backward, left, right, up and down, rotate it, make it take off and land smoothly using Python code. After that, we will learn how to receive and display the video live stream from the drone so we can process camera frame in real time. Once we have the video feed, we will move into AI-powered control. We will build a hand gesture recognition system using OpenCV, MediaPyte and MediaPyte Task API, allowing us to fly the drone using nothing more than our hand gesture. Then we will take it one step further by using full body pose detection. Instead of controlling the drone of our hand alone, we will use entire body posture and movement to navigate the drone naturally. Finally, we will learn how to make the drone automatically follow predefined path. This introduces the fundamental of autonomous drone navigation and prepare you for more advanced drone programming projects. Whether you are a beginner in drone programming or an experienced Python developer looking to explore your robotics and AI, this course will give you practical hands-on experience through real projects. So let's get started and begin our journey with exciting world of drone programming with Python. Hey, before we start our practical journey, this course is part of drone programming with Python using PySimverse Simulator. If you want to learn drone programming in very organized way and if you want to access the source file, then you can enroll the course. And time to time, I am going to update the new missions on this course. And remember, you don't need to pay high price to enroll the course. I will provide the link at my description. It is the fresh new course on Udemy. So don't forget to check out this course for once. So let's start our journey. So the first thing we will need is PySimverse. PySimverse.com. So what exactly is PySimverse? It is a drone simulator that has a lot of missions, where you can program your drone to execute those missions. For example, here you can see 4 lines of code. Using 4 lines of code, you can basically run the simulator, you can connect to it and fly. So it says from PySimverse you need to import drone class, then using that drone class you need to create an object, then you need to connect to the drone, then you need to take off the drone. And if I press the run button, instantly it's going to fly in the drone. Let me show you. So as you can see, after press the run button, instantly it fly the drone. So that's how simple it is. Just 4 lines of code. You can start running. So that's the idea. You can download, connect, control and optimize it. Without going into the real hardware, you can practice all of this here. It provides powerful simulation features such as camera simulation, physics engine, Python API, multi-drone swarms, environment builder, also telemetry data. And these are some exciting game scenarios in PySimverse, such as jogging tracking, drone delivery, drone obstacle, warehouse surveillance, drone navigation, car chase, drone show, many more. If your computer is powerful enough, then you can run all of it. Now, some of them are free and some of them will be paid. Basically, PySimverse bridges the gap between Python-driven logic and industrial-grade simulation environment with zero latency integration pipeline. And if we talk about the native stack support, it is supported by Python, OpenCV, YOLO, LLM, and AI. So it provides very strong ecosystem. It is the future of drone development. In traditional development, you have to pay high hardware cost, environment dependency, long iteration cycle, and many more. You need to spend hours to charging the battery, calibrating IMUs, and setting up telemetry gears. But with PySimverse, it is zero financial risk, instant sandbox environment, and rapid Python iteration. You can execute your Python script and see results instantly with real-time physics and data logging. Also, it is empowering the future autonomous flight. PySimverse provide a high-fidelity environment to bridge the gap between Python code and physical drone hardware across multiple industries, such as security industry, agricultural industry, delivery industry, and rescue missions. So currently, drone is the most important hardware in every scenario in our life. For drone show, agriculture, rescue, delivery, cargo drones, surveillance, etc. Now let's jump into the pricing and free section. If we talk about the plans, it comes with a free plan, where you can perform basic missions, access to 3 levels. Also, you can get some updates, new updates on levels. And here you need to pay quite a good amount to access the pro version. You can get lifetime access, live session access. Also, you are able to participate in competitions. Then you have access all levels. You can get updates, new levels, premium features, and many more. But in that tutorial, we are focusing on the free version. Yes, you can do lot of stuff with free version also, if you know coding and approach. Now, to download the system in your local machine, you need to choose your operating system. If you are Windows user, then download for Windows, and if you are Mac user, then download for Mac. I am Windows user, so I'm going to download it for Windows. So I click download for Windows button. Instantly it's going to download the simulator on your system. Now after complete the download, open the download folder and just double click on it. And you need to allow everything to your system. And don't forget to create desktop shortcut. I already downloaded it, so I'm not going to download it again. Just press next, 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 install and complete. After that, after download all of it, after download the simulator, let's open the simulator. Now here you can see the application icon in our desktop. So I'm going to double click on it. After double click on it, first it's going to show you this option, this start button. If this program need updates, then instantly it's going to start updates. Then you need to download the updates. Otherwise, just click on start button. It's going to start the simulator. And this is our simulator. First, I'm going to turn off the sound, the default sound. And from here you can turn off the sound. First of all, you need to create account. You need to create account using your email and password. After that, here you can see the profiles, how many level you complete, also your total scope and how many stars you earn. Currently, these are the all missions provided by this simulator. Obstacle avoidance, line following, body follower, hand gesture, image capture, traffic surveillance, car washer, agriculture, drone show, and building inspection. But for free version, you can access these missions: free play, garage, image capture, hand gesture, body follower, line following, etc. And to access obstacle jogging, traffic surveillance, you need to upgrade your account. But don't worry, this is enough if you play with free version. Don't worry, here you can learn all the basic of drone programming, how you can capture images from your drone camera, how you can control the drone using hand gesture, how you can fly your drone with remote control and keyboard, etc. And don't worry, this simulator application is also flexible. You can open side by side your simulator and your code editor to run the code and play the drone program on it and control the drone using your program. So it is responsive. This application is responsive. So this is it for this tutorial. From the next tutorial, we are going to start the real practical. We are going to start with free play and we are going to learn some basic movements. We are going to start it from very basics. And this course is for beginners who have basic knowledge about Python programming language, computer vision OpenCV, and very enthusiast to learn drone programming. So see you on the next tutorial. So as you can see, side by side, I open my Visual Studio Code editor and the PySimverse application in my window. Now before we start coding, let me install a module. So I'm going to open Windows PowerShell. And here I'm going to type pip install PySimverse, PySimverse. Then hit enter. I already downloaded it, but you need to complete the download process. Now let's back to the Visual Studio Code editor. Here you can see I create a Python file first_flight.py. Now in our first flight file, I am going to import the module. Some type from PySimverse, I want to import drone, this one. As you can see, it do not show any warning. It's mean we successfully install the module in our system. And if I run this now, let me show you. If I hit the run button, as you can see, it do not show any error. It's mean it's worked fine. Now we are good to go. Next, we are going to simply create a drone object. So here I'm going to type drone equal to, I'm going to create a drone object. After that, we need to connect to the drone. So here I'm going to type drone.connect. After that, we will go to the free play option, this option, and click on it and click start. And here you can see a mission garage. This mission is for practice flying in a familiar garage environment with no time limit. So there is no time limit in that mission, and this mission is very good to start for a beginner. So I'm click on the start button. After open the mission garage, if I run this code in my terminal, let me show you. After hit the run button, now you can notice in our terminal it print response connected. So we successfully established the connection with this drone, and that's good. It's a good sign. We did not tell our drone to fly, but we successfully established the connection. Next, I'm going to import time module. So here I'm going to type import time. That's it. We need that. Then I'm going to take off the drone. So here I'm type drone.takeoff. After that, here I'm going to type time.sleep function 5 seconds. So before it shut off, it's going to fly it for 5 seconds. Now if I run this code, it's going to start the drone and it flight for 5 seconds, and after 5 seconds it's going to back to its own position again. Let me show you. And before I run it, we need to make some correction. We need to provide underscore sign after take off. Otherwise, it's going to throw an error, attribute error. Now, if I set this file again and run this code in my terminal, let's see is it work properly or not. After hit the run button, as you can see, it's going to start my drone and it's going to hover it for 5 seconds. And then again it's back to its own position. So we successfully take off our drone. At the same way, you can type drone.land, drone.land. land function. And also I'm going to provide little delay to this function. So I'm type time.sleep, and here I'm going to pass 1 second. 1. So basically this is your first slide, how you can take off and how you can land your drone. And the good thing is you don't have to connect manually anything. Everything is done internally. Just you need to do to run the code. And it's going to hover your drone for 5 seconds, and let me show you. Now after takeoff the drone, after reach 1 meter height, it's going to take 5 second delay. It's going to hover for 5 seconds, and then it's going to land the drone. So in this tutorial, I try to explain how you can connect your drone, how you can take off your drone, and how you can land your drone. At the next part of this tutorial, we are going to learn how we can do basic movement, such as we can move forward, how we can move it backward, etc. So thanks for watching this video. Stay tuned for the next part of this tutorial. Hey, before we start our practical journey, this course is part of Drone Programming with Python using PySimverse Simulator. If you want to learn drone programming in very organized way, and if you want to access the source file, then you can enroll the course. And time to time, I am going to update the new missions on this course. And remember, you don't need to pay high price to enroll the course. I will provide the link at my description. It is the fresh new course on Udemy. So don't forget to check out this course for once. So let's start our journey. Hey guys, good to see you back. This is the second tutorial related drone programming with Python. And at that section, we are going to learn basic 3D movements. You have two options of movements. The one way is you can provide specific distance. You will say move forward 20 centimeter. And the other way, you can provide speed to your drone. You can provide continuous speed rather than saying move this much of distance. And both of have their own applications, also their own usage. So we will learn both of them to understand how it's work. So let's look at the first example, where we will do up-down movement, left-right movement, rotation, and all of that. Now we can say this 3 line of code, the first 3 line of code is the initialization part, and this 2 line of code is the last part, and between it we can do our code. It is the takeoff part and it is the landing part. So whatever code we write here. So the first thing, we are going to understand how we can move our drone forward and backward. With that, we are going to learn how we can move our drone up and down. After takeoff, I want to move it up again and then down again. Let me show you. So to start the drone, I want to move down the drone. Let me show you. So here I'll type drone dot move down. I'm going to use move down, and I want to move down 20 centimeter, 20. So I pass 20 here. By default, when we take off the drone, it's go up to 1 meter, and then we command move down 20 centimeter. So 1 meter equal to 100 centimeter. If we reduce 20 centimeter from it, then flight altitude is 80 centimeter. So after reach 100 centimeter, again it moved down 20 centimeter. If we use this command, move down. After that, I'm going to provide little delay. So here I'm type time.sleep, and I'm going to pass 3 seconds. So after delay 3 seconds, again I'm going to move up the drone. So here I'm going to type drone dot move up, and I want to move this drone upward nearly 40 centimeter. So I pass 40 here. And at that height, I want to hover the drone for 3 seconds also. So I use time.sleep, this delay, and set that fine. Then it's going to reach down. And after complete 3 second delay, again it's going to land the drone. So if I run this code, first it's going to reach 100 centimeter, then it down 20 centimeter, and again it rise 40 centimeter. Let me show you. So if I run this code in my terminal, you can notice first it rise up to 1 meter, then it go down 20 centimeter, again it reach 40 centimeter after 3-second delay. So it's going to hover on 3 seconds here and then it's going to land the drone. So this is the exact behavior we expecting from the drone. Now let's see how we can move our drone left side and right side. Now instead of move down, first I'm going to duplicate this line and comment out previous line. Here I'm going to say I'm going to move this drone this time left side, left, move left 20 centimeter, and instead of moving up, here I'm going to say move right 40 centimeter. That's it, and I'm going to save this file. Now let's try that out and see is it work properly or not. So to save the file, if I hit the run button, as you can see, first it's going to start the drone and reach up to 100 centimeter. Then it's going to move to the left side 20 centimeter, and next it's going to move to the right side 40 centimeter. Then after hover for 3 minutes, it's going to land the drone. At the same way, we can move our drone forward and backward. Just type move backward instead of right, backward 40 centimeter and move forward 20 centimeter and set that again and hit the play button. Now you can see after reach 100 centimeter, it moved forward 20 centimeter. Then again after 3 seconds, it moved backwards 40 centimeter, and after hover for 3 seconds, it's going to land the drone. After that, we are going to learn how we can rotate the drone. So I'm going to comment out these lines. I don't need it now. And here we are going to rotate the drone. To rotate the drone, just you have to type drone.rotate function, rotate. And inside the round braces, here you can pass the value. I want to rotate this drone up to 5 degree at clockwise direction. Otherwise, you can rotate it up to 10 degree. So if I save the file and run this code in our terminal, you can notice after reach 1 meter height, it's going to rotate the drone 10 degree. You barely experience the rotation. At the same way, if you want to rotate it more, suppose if I add 40 degree instead of 10 degree and then set the file and run this code again, let me show you. Now you can clearly experience the rotation. So after reach 1 meter height, it's going to rotate the drone 40 degree at clockwise direction. And if you rotate it anti-clockwise direction, yes you can, just you need to pass negative value here. So you need to pass minus 40 degree, otherwise 50 degree. If I make it 50 degree, then again it's back to its own position. So after pass minus 50 degree, I'm going to save the file and run this code in my terminal. And now you can notice, now it's going to rotate the drone anti-clockwise direction. It rotates this drone anti-clockwise direction. Not only that, also we can set the speed of the drone. Let me show you how. So here I'm going to comment out this line. So here I'm going to type drone dot set speed. Set speed. And I'm going to set speed at centimeter. So I'm going to set speed. By default, it moves 20 centimeter per second speed. And here I'm going to set it 50 centimeter per second speed. So in 1 second, it's going to cover 50 centimeter. And I want to move it at forward direction. So I type drone dot move forward. Here I'm going to move the drone 200 centimeter. With that, after reach 200 centimeter, it's going to hover for 3 seconds. So I'm going to type time dot sleep 3 seconds, and I'm going to save that file. After save that file, if I run this code in my terminal, so from this place it going to move upward 1 meter. After reach 1 meter, it's going to move forward at 50% per second. So as you can see, after reach 1 meter height, it moved forward 200 centimeter with the speed of 50 centimeter per second. And then it hover for 3 seconds and land the drone. So this is the first method how we can control the drone. At the next part of this tutorial, I'm going to show you the second method how we can control the drone. So thanks for watching this video. Stay tuned for our next tutorial. Hello guys, good to see you back. Now we will look into the second method how we can control the drone. As you can see here, I create a new Python file rc_control.py, and here I import the starter template. Basically in this tutorial I'm going to talk about continuous control. So let's jump into the mission free play, and I'm going to click the start button, and from here we are going to open carriage option. After that, I'm going to silent the drone sound because I don't want the noisy sound. As I told you, it is the second method to fly our drone, and we are going to continuously fly the drone, so we need a while loop. So here I'm going to type while true. As I told you, it is continuous, so it needs a loop that need to keep updating continuously. Otherwise, it sends one value at a time. So we need to keep giving the value again and again. So here I'm going to use a function drone.sendRcControl. So type drone.sendRcControl, this option, this function. Then I'm going to use round braces. And now we need to pass some parameter here. Now over here we need to pass left right value, forward backward value, up and down value, yeah value, camera angle, etc. But I'm not going to provide the value directly. I'm going to create a variable for that. Let me show you. So here I'm going to define the variables such as left right underscore right equal to, I'm going to pass 0 here. Then I'm going to define another variable forward backward also equal to 0. Then up and down also equal to 0. At last we need to pass the rotation value. To rotation value, here we need to define yaw value, yaw, yaw velocity, otherwise u equal to 0. Now we are going to assign this value over here. So first I'm going to assign left right. So first I'm going to provide left right, then forward backward, up and down, and yaw. So I type tab here because it already suggests me to do that. Now we are able to change the value from here. Here if you provide value in minus, then it's move backward, and if you provide value in positive, then it's move forward. So here I'm going to provide the forward value. So here I'm going to assign 50. So at 50 centimeter per second speed it moves forward, and it's continuously move forwards because of this while loop. And for the other values such as left right, up and down, I said 0 because if we change the value, if I provide left right value 10, so at 10 centimeter per velocity it's going to move this drone right side, and it's continuously doing that because of this while loop. So here I just want to move the drone forward at 50 centimeters per second speed, and then I'm going to save that file. Now what's happened if we run this code? So let's run the code. So if I hit run button, as you can notice, first it take off the drone. It will take off, and then with the speed of 50, it will keep going forward. As you can see, it's continuously keep going forward. Here we set forward backward value 50, and now it got crashed with wall and stuck because of this while loop. It continuously fly the drone, that's why it crash. Now this code has major issue. The drone will move forward forever because of the while true. Our loop never stopped, so the drone.land function never reached. And to resolve the issue, now I am going to continuously move the drone forward for 5 seconds and then land safely. Now at first, before the loop, I am going to store the current time. So after define the variables, here I will type start underscore time equal to time function, this one. As you know, this function time, it return the current timestamp in second. Next, we need to run this loop continuously for 5 seconds. So here I will type, I'm going to change the condition a little bit. Instead of true, while time function minus while time minus start time less than 5 seconds. Then I want to run this RC control. Function. It's mean if elapsed time is less than 5, then continuous the loop. And after 5 seconds, the loop will stop. Then inside this while loop, here I'm going to add a little pause. And I'm going to type time.sleep, and here I use 0.1 second pause. Now the question is why I use that pause. Because it is important to prevent excessive command sending. Also it reduces CPU usage and creates smoother control. Without this pause, thousands of commands are sent every second. And this is not I want. Next, I am going to stop the movement of RC control. So outside the while loop, I am going to stop the movement of RC control. So I'm going to type drone.send underscore RC control, and I'm going to set all the values 0, 0, 0, 0. Left, right value 0, forward, backward value 0, up and down value 0, and rotating value 0. And then I land the drone and add little delay using time.sleep function. And I'm going to save the file. Now, if I run this code, it's going to safely land the drone. It's not going to crash this time. It continuously move forward the drone for 5 seconds. After reach 5 seconds, it's going to land the drone. It's going to stop the loop. Let me show you. So after save the file, if I run this code in my terminal, you can notice first it start the drone and it gain altitude, default altitude. After that, it move forwards. And after reach 5 seconds, loop will stop and land the drone over these boxes. So here we safely land the drone with the help of while loop. And our drone will move forward at 50 centimeters per second speed. So this is it for this tutorial. In this tutorial, I show you the second method to fly our drone with the help of RC control. From the next tutorial, we are going to start our mission garage. Here we have total 3 missions in this application, level 1, level 2 and level 3. We are going to complete all of these in our upcoming tutorial. So thanks for watching this video, stay tuned. Hello guys, good to see you back. Once again, I am back with a new tutorial. And in this lesson, we are going to learn how to control a drone using the keyboard in PySimverse Simulator. Keyboard control is one of the most important skills when working with drone, robotic and real-world autonomous system. Before building advanced AI-powered or computer vision-based drone application, it is essential to understand how to manually control a drone and send movement command programmatically. By learning keyboard control, we can interact with the drone in real time. Also, we can test its movement and understand how commands such as moving forward, backward, left, right, up and down and rotation are translated into actual drone action. This knowledge serves as the foundation for more advanced projects, including object tracking, face following, gesture control, autonomous navigation, and obstacle avoidance. In this project, we will create a dedicated keyboard control module that listens for keyboard inputs and convert them into drone movement commands. We will then integrate this module with our main drone program, allowing us to pilot the drone using simple keyboard keys. By the end of this lesson, you will have solid understanding of real-time keyboard event handling, drone movement control, and modular Python programming techniques that can be applied to both drone simulator and real-world drone application. So what are you waiting for? Let's get started coding. As you can see side by side, I open my simulation application, PySimverse and our Visual Studio code editor. And today in this tutorial, we are going to learn professional style drone keyboard control. And to create that, we are going to create two separate files. So here I'm going to type our first Python file main.py, and then also I'm going to create another Python file. This is our executable file, and for keyboard control, I am going to create another Python file keyboard_control.py. That's it. Now let's back to the main file main.py. At first, we need to import the necessary modules such as drone. From PySimverse, we need to import drone. So here I'm type from PySimverse import drone class. After that, I am going to import time module here. So I'm going to type import time, and then I'm going to open my Windows PowerShell because we need to install a new module. So here I open my Windows PowerShell and I'm going to install a module, and our module name is keyboard, pip install keyboard. I already downloaded this module in my system, but you need to complete your download process. As you can see, requirement already satisfied because I already downloaded it, but you need to complete your download process. Now, what can I do with this module? The keyboard module allow you to detect keyboard input globally, create hotkeys, and simulate key passes, and monitor keyboard event in Python. Next, using drone class, I am going to create a drone object. So here I am type drone equal to drone object using drone class. After that, we need to connect the drone. So here I'm going to type drone.connect, this function, this method. Now if your connection established successfully, I want to print a statement in my terminal, and I want to print drone connected. Then I'm going to take off the drone. So here I'm going to type drone.take_off function. After take off the drone, also I'm going to print a statement in my terminal. Here to type print drone takeoff successful. After that, I want to pause the program for 2 seconds. So here I'm going to type time.sleep method, and I'm going to wait for 2 seconds, and I'm going to pause this program for 2 seconds. It's give the drone time to stabilize after takeoff. So at first we import drone class from PySimverse library. This class provides a method to connect, take off, land and control the drone. And then we import Python's built-in time module. We use it to adding delays with sleep function. Next we create an instant object of drone class. Through this object, all drone command will be sent. Then after that, we established communication with drone simulator, because without connecting, no command be sent. And next we send a takeoff command. The drone rises automatically and starts hovering if we use this command takeoff. Now as I told you, in that tutorial we are going to control the drone in our keyboard, using our keyboard. So we need to create a function, and to create that function, I'm going to jump into the keyboard_control.py file. Yes, I'm going to create that function separately because I want to use that Python file, this keyboard control file again and again in our upcoming projects. That's why I create it separately. Now at first we need to import the keyboard module. So here I will type import keyboard. This module allows Python to detect keyboard key press globally. Next I'm going to define a function, the main function which is going to control our drone, and it's going to take key input. So I'm going to type def get key input. This is our function name. Basically this function going to read the keyboard state and return movement commands. Now inside that function we need to define the movement variables. We need to initialize the movement variables such as left right. I'm going to set left right 0. After that I'm going to define forward backward, and I'm going to set forward backward also 0. After that, I'm going to set up and down. Up and down value also 0. And then I'm going to pass the rotation value, yaw. And also I'm going to set it 0. YAW also 0. The first value left right, it control right and left movement. And we set the initial value 0, it's mean no movement. And same for forward backward. And same for up and down. And same for rotation. For up and down, if we pass positive value, then it's move up, and if we pass negative value, then it's move down. Similar to yaw, if we pass positive value, it going to rotate the drone right side, and if we pass negative value, it going to rotate the drone left side. After that, I'm going to set the movement speed value. So here I'm going to define speed 50 centimeter per second. So whenever any movement key is pressed, such as left right key, backward forward key, up and down key, in that case corresponding value become 50. At 50 centimeter per second speed, it move the drone. Next, I'm going to move the drone left and right side. For that, I'm going to type a single line comment, and here I'm going to set a if condition, and I'm going to type if. I'm going to use a function from keyboard method, and here I'm going to use a function from keyboard module, and our function name is underscore pressed. So I'm going to type keyboard dot is pressed function inside the round braces if user enter inside the double quotes left arrow in his keyboard. So I'm going to type left, then inside this if condition, here I'm going to set left right value equal to minus speed value. It's mean here I pass negative speed value. So if user press left arrow in his keyboard, then it going to rotate the drone at left side, because as I told you, if we pass negative value, it going to move the drone left side, and it going to move the drone speed of 50 centimeter per second. Else if user press right arrow, then I want to set positive value, left right value, the speed value itself 50. After that, we need to handle the forward backward movement. So I type a single line comment forward backward, and I'm going to set a condition if keyboard dot is pressed up arrow, then it's going to set forward backward value positive. If user press down arrow, then it's going to set the value in negative. So if user press up arrow, then it's going to move the drone 50 centimeter per second at forward direction. And if user press down arrow, then it's going to move the drone at backward direction at 50 centimeter per second speed. After that, we need to control the up and down movement. I want to say the altitude of the drone, how we can gain height and how we can decrease height. So for the up and down movement, here I'm going to type another single line comment up and down, and if keyboard dot is pressed W, if user press W in his keyboard, then I want to gain the altitude. So here I'm going to type up down value in positive, and if user press S, then I want to reduce the altitude, so I pass the value in negative. And then comes the rotation part, yaw. As I told you, yaw is used to control the rotation. If I pass negative value, then it going to rotate the drone at left side, and if I pass positive value, it going to rotate the drone at right side. So if we press A, it going to rotate the drone at left, and if we press D key in our keyboard, it going to rotate the drone at right side. And then I return all the values we created, and we need to return the values in a list. So I'm going to use square braces, and I'm going to set that file. So this function going to return a list that contain all movement commands, and we are going to call this function getKeyInput in our main.py file. It's going to return total 4 value in a list. Suppose if we press right arrow, then it's going to send left right value positive 50, and if we press left arrow, then it's going to pass negative value in left right value, and other value remains 0. This function going to provide global keyword detection, faster response, cleaner code, and better for simulation and robotics. That's why I create that function. Now, at the next part of this tutorial, we are going to jump into the main.py file, and we will call the function from the keyboard control.py file, get key input. So this is it for this tutorial. Stay tuned for the next part of this tutorial. Hello guys, good to see you back. This is the second part of this tutorial. In that section, we are going to learn how we can control our drone with our keyboard. In our previous tutorial, we already worked on this function called get key input. And for this function, we create a separate file, keyboard_control, that's going to control the keyboard. It's going to take keyboard input from the user, and according to the keyboard input, it's going to set the value of the drone, such as left right value, forward backward value, up and down, and rotation value. Also, we mention speed in our code. Now, let's jump into the main.py file. At first, from the keyboard control.py, we need to import the function. So here, I'm going to type from keyboard control, I'm going to import get key input function, this method. Now after takeoff the drone, also we print a statement, drone takeoff successful, and then we take a little delay, little sleep, 2-second delay. Now I'm going to start while loop, but I'm going to use the while loop in a try block because also we need to handle the error. So I'm going to type try inside the try block. Here I'm going to type while true. Then inside the while loop, we need to get the keyboard input. We need to call the function. For that, I'm going to define a variable, and our variable name is vals, means values. Vals equal to get keyboard input method. Here I start a try block. It is useful for safely landing the drone when stopping the program. So also we need to handle the exception part. So here I'm going to create the except block to handle the error. So type except, and for now inside this except block I'm going to type pass. Later, I'm going to do our stuff because I don't want to show any error in our code. That's why I use pass in our except. Now after try, we run a while loop. It is a forever loop until interrupt. It's going to continuously check keyboard input and send control to command. We already learned about it in our previous tutorial, but we do not use it properly. But in that tutorial, I'm going to use it properly. And here we call the function from keyboard control.py file, and our function name is get key input. And as you know, this function going to return a list that going to store 4 movement value such as left right, forward backward, up and down, and rotation. As I told you, it's going to store a list. So from the list we need to extract the individual values using its index number. So for the first value such as left right, here I'm going to access the first index number 0. So I type left right equal to vals, inside the square braces I access 0 index. At the same way, I'm going to access forward backward, then up and down, and at last I'm going to access your value, means rotation, using index number 3. Next we need to use a function called rc control. We need to send rc control command. For that, here I'm going to use a method from drone class, drone object. So type drone dot send rc control. Send rc control, this function. Then inside the round braces, inside it, I'm going to pass the values such as left right, forward backward, up and down, and rotation. I pass these values. Using this function, we can send movement value to the drone. That's why I use these values. Next, I'm going to print the values in my terminal. So here I'm going to type print statement. Inside the round braces, one by one, I'm going to print the values. For that, I'm going to use f string. Then inside the double quotes, I'm going to type LR. LR stands for left and right. Then inside the curly braces, I'm going to pass the left right value. So I'm going to type left right underscore right, this one. Then one by one I'm going to print all the values, such as I'm going to type f string again, and I'm going to print forward backward value, up and down, and rotation value. That's it. Then I'm going to use little delay, and I want to use 50 millisecond delay. So I type time.sleep 0.05 second. It's mean 50 millisecond. We use to prevent the loop from running too fast. It reduces CPU usage. That's why I use this delay. And next we need to jump into the except part. And here we need to handle the keyboard interrupt. So I'm going to type except keyboard interrupt, and inside this except block, first I'm going to print drone landing, this statement in my terminal. It's going to display this message if any error occurred in our try block. Then here I am going to send a RC control code. I want to stop all the movements, so I type drone.rc control and I set all the values 0. After that I am going to land the drone, so type drone.land function. And next we need to wait for landing completion. For that I'm going to use little delay, so I'm going to use time.sleep method again, and I'm going to wait for 1 second. It gives the drone 1 second to complete the landing process. After that I'm going to display a success message, so I'm going to type print drone landed successful. That's it. So let's save the file. After save this file, here I'm going to run the code in my terminal. But before I run the code in my terminal, let's open free play option and start this garage mode. And then I'm going to turn off the sound, the drone sound. I don't need that sound. And now I'm going to run the code in my terminal. So I'm going to hit the run button. After hit the run button, we need to wait for some time to start the drone. As you can see, respawn connected, drone connected. So automatically it's start the drone and gain altitude. After that, I want to move this drone forward. So here I'm going to press up arrow. If I press up arrow, as you can see, it moved the drone forward. At the same way, if you want to move the drone backward, here you can pass down arrow. And if you want to move the drone left side, you can press left arrow. It moved the drone left side. At the same way, if you press the right arrow, it moved the drone right side. Now, if you want to gain the altitude, you can press W. After press W, as you can see, our drone gain altitude. And if you want to reduce the altitude, then you need to press S. After press S, it reduces the altitude. So we can move the drone anywhere. We can gain any height, and also we can rotate our drone. If we press A, it's going to rotate the drone left side. But the problem is our rotation speed is very high, because here we set the speed. Here we set the speed 50 centimeter per second. So at a time, it's going to rotate the drone 50 centimeter per second speed. So we need to reduce the speed. So let's back to the code again. To land the drone, kill your terminal. Then it's going to automatically land the drone. Now after that, here I'm going to define another value. So I'm going to duplicate this section, and I'm going to name this variable your speed. It's main rotation speed, and I'm going to set it, for now I'm going to set it 3. And I'm going to copy this variable, your speed. And then I'm going to jump into the your section and replace speed with your speed, with new rotation speed. For negative value, I pass negative yaw speed, and for positive value, here I pass positive yaw speed, and save the file again. Then back to the main.py file, and I'm going to run the code again in my terminal. Now after run the code, as you can see, it's going to connect to the drone and it's going to fly the drone. After gain the altitude, it works fine as it is. But if I press rotation, now slowly it rotates the drone. Now we can control the rotation speed of this drone. If we press the rotation key and hold it, it rotates the drone infinitely. If you want to rotate the drone right side, then you can press D command. You can press D keyword in your keyboard, and if you want to rotate the drone left side, you can press A. So this is how you can control your rotation. And if you want to decrease the rotation value more, in that case again you need to change the value. You need to set it 1. I think 1 is the perfect value for it. So let's kill the terminal and save the file and back to the main.py file. And again I'm going to connect to the drone. Now after connect to the drone, as you can see, it gain altitude. Now if we press A, it's going to rotate the drone left side. But the benefit is it rotates the drone very slowly, and this is what we need to control the drone rotation speed. We can move our drone backward, also we can move our drone forward, anything. We can gain the altitude, we can reduce the altitude, we can move the drone left side, also we can move the drone right side, whatever. So I hope now the concept is clear for you. How can we control the drone from our keyboard? And this is one of the best and easy way to control the drone. Also you can use Pygame module for that. But the problem is, with Pygame module, you need to open an unnecessary window for that. That's why I skip Pygame module and use keyboard module. So this is it for this tutorial. Thanks for watching this video. Stay tuned for our next tutorial. Hello guys, good to see you back. In our previous tutorial, we learned how we can control our drone with keyboard. But we left one thing. We do not create any command to land the drone successfully. In our previous tutorial, we learned how we can control the movement of our drone, such as forward movement, backward movement, left movement, right movement, up and down. Also, we control the rotation. But we do not create any command that going to land the drone. If we exit this window, then automatically it land the drone, but we do not create any command that particularly trigger the landing the drone. But in that tutorial, I'm going to resolve that problem. So let's back to the code editor. Now at first, I'm going jumping to the keyboard control.py file, this one. Then I scroll down a little bit, and after else if condition, I'm going to create a variable. And my variable name is land. So here I'm going to type land equal to keyboard dot is pressed. If we pressed L in our keyboard, then it's going to store the command in that variable. And then I return that variable in my list. And I'm going to save that file. Now after return the value in a list, let's jump into the main.py file. Now here we need to access that value. So here I'm going to type land equal to, so from the list I access index number 4. After that I'm going to set a if condition. So here I'm going to type if land, then inside this if condition I want to print a statement. So I'm going to type print, inside the round braces, inside the double quotes, I'm going to type landing drone. Then I'm going to simply break the loop, nothing else. Break. Next, I'm going jump into the except block. So here I'm going to type except, inside the round braces, keyboard interrupt, comma, system exit, this one, system exit. Then inside this exit condition, I'm going to print a statement. Basically here I'm going to type emergency landing the drone. So first I'm going to use a new line character \n, and I'm going to type emergency landing triggered. and I'm going to save that file. After that, we need to go and jump into the finally block. So here I'm going to type finally. Then inside this finally block, here I'm going to type, first I print a statement stopping drone movement. Then I'm going to pass a RC control command 0000. I'm going to set all the values 0, so automatically it land the drone. Then I use drone.land function to land the drone. And here I add little delay to land the drone using time.sleep function, and I save that file. After save that file, I'm going to run the code in my terminal. But before, let's open the garage free play option. So I clicked start button, and here I'm going to turn on the drone. Let me show you. So I'm going to run the command in my terminal, and as you can see, respawn connected, drone connected, and by default it take off the drone. Now we can perform basic movement in my drone because we have keyboard control on it. Forward, backward, left, right, up and down. And if you want to land the drone by pressing command, so if I press L in my keyboard, it's going to land the drone. Instantly it's going to land the drone. So this is how we can successfully land the drone, and we follow very professional approach to do that. So I hope the concept is clear for you. Thank you very much. From the next tutorial, we are going to start the mission. We are going to start garage mission. Here we have total 3 levels, and one by one I'm going to complete all the levels. But for the level 1 and level 2, we are going to follow the simple approach to complete the level. We are going to pre-program the drone to achieve the target, but for the level 3, we are going to use keyboard control. So we can manually control the drone and achieve the target. So this is it for this tutorial. Thanks for watching this video. Stay tuned for the next tutorial. Hey, before we start our practical journey, this course is part of drone programming with Python using PySimverse Simulator. If you want to learn drone programming in very organized way, and if you want to access the source file, then you can enroll the course. And time to time, I am going to update the new missions on this course. And remember, you don't need to pay high price to enroll the course. I will provide the link at my description. It is the fresh new course on Udemy. So don't forget to check out this course for once. So let's start our journey. Hello guys, good to see you back. From this tutorial, we are going to start our mission. And we are going to start with mission garage. We are going to start garage mission. Fly over targets in a garage setting. If I open this garage mission, here we have total 3 levels. Level 1, level 2 and level 3. For the first 2 levels, I am going to pre-program the drone and achieve the level. But for the 3rd level, I am going to use keyboard control. We are going to manually control the drone and achieve the level. So from the next video, we are going to start our first level. Hello guys, good to see you back. Once again, I am back with a new tutorial related drone programming, and today in this tutorial, we are going to start our mission. At first, we are going to start garage mission. If I click the start button, as you can see, we have total 3 levels in this mission. And one by one, I am going to complete all the levels. So let's start with the first level, and this is the basic level. As you can see, in level 1, fly the drone to target 1 and land to complete. So basically, we need to fly the drone and we need to land the drone in this circle. According to map, as you can see, we need to fly the drone, then we need to go forward, and then we need to go right direction. Otherwise, first you can take off the drone, then you can go right side, also you can move forward to reach the circle, the destination. Also at top right corner, you can see the minimap. So before I start coding, first I am going to turn off the volume because I don't want propeller sound, and because it concatenates with my voice and it creates very noisy sound. That's why I'm going to turn off the sound. After that, let's back to the Visual Studio Code. At first, we need to import the module. We need to import PySimverse, and from PySimverse, we need to import drone object. So here I'm type from PySimverse, I'm going to import drone. After that, also I'm going to import time module. So type import time. Then, as you know, we need to create a drone object using drone class. So to create the object, here I'm going to define a variable and our variable name is drone. Drone equal to drone object. After that, we need to connect the drone. So type drone dot connect and the round braces. After that, after connect to the drone, also we need to take off the drone. So I type drone dot take off. Then between them we need to type our code. You know that. And also after takeoff, at last we need to land the drone. So type drone dot land function. Then I want little 1 second delay. So here I will type time dot sleep 1 second. So let's drive it forward. First I'm going to move forward. I will go forward, then take right direction. So here I will type drone dot move forward function, and inside the round braces, right now we don't have the actual value. So we need to make assumption and put the value. I think I'm going to move total 2 meter from forward direction. So I'm going to pass 200 centimeter. We don't know the exact distance, so we need to experiment with that and find out the correct value. After that, I am going to save that file and hit run button. After hit run button, as you can see, it return it is connected with our server, then it will take off. It take off the drone, as you can see, it take off, then it going to move forward and it going to stop at 2 meter forward direction. Also you can see the minimap over here. Then it land. So here we need to move little bit forward again. And by default, it's back to its own position again. So we need to move little bit further. So I'm going to increase the value. Here I'm going to make it 250 centimeter. That's great. And save that file. To understand the position correctly, we need to focus on minimap also. Let's run the code and see how far it can travel and is it aligned with this point or not. So I'm going to hit the run button, and as you can see, it connected, then it take off. After takeoff, it's going to move forward, and you can notice on here now it's flying, and after fly 250 centimeter, it's going to land the drone. Now you can notice it's nearly aligned with this point. Now we need to move right direction from this point to this point. So I'm going to add another command. We need to move right direction. To move toward to right direction, we need to type drone dot move right. And here I am going to pass a value. Now the problem is I don't know the exact position of this value. So we need to make assumption. So here I'm going to pass 230 centimeter. And I'm going to save that file and run the code in my terminal. After run the code, as you know, it's going to take off and move. First it's going to move forward, then after reach 250 centimeter, then it's going to move right direction. But we need to focus on this top view map, this mini map. After reach the position, as you can see, it's moved right direction 230 centimeter. So it's little bit far from this. It's nearly reach, but it is not accurate. As you can see, task accomplished in 34 seconds. It is not accurate, but we reach the destination. So this is our first mission, and we complete our first mission nearly accuracy. So if we pass 250 here, then it accurately land the drone to this circle. So our level 1 is accomplished. At the next part of this tutorial, I am going to jump into the level 2. Here in this tutorial, we need to visit target 1, then target 2 and land to the finished task. We need to guide the drone through all glowing checkpoint in the garage and finish the mission by landing precisely on the final illuminated pad. And I'm going to complete this level 2 in our next tutorial. Stay tuned for the next tutorial. Hello guys, good to see you back. This is the second part of the garage mission, and here we are going to complete level 2. So I'm going to hit start button. Now in that tutorial, first we need to take off the drone, then we need to fly over the first circle, then we need to fly over the second circle, and at last we need to land the drone at third circle. So at first let's import the important module that we need to take off the drone. So first I'm going to import PySimverse, and also with that I import time, and from PySimverse we import drone class. Now using this drone class we need to create an object. So here I'm going to type drone equal to drone object. After that we need to connect to the drone. So here I'm going to type drone dot connect. Then we need to take off the drone. So here I'm going to type drone dot takeoff function. After that here I'm going to land the drone. For that I'm going to type drone dot land, this function, and it's going to land the drone. And then I'm going to use little delay, 1 second delay. So type time dot sleep 1 second. That's it. And I'm going to save that file. Now according to our mission, first we need to take off the drone. Then after takeoff, we need to move left direction. And then we need to move forward. Basically we need to hover the drone above this circle. And we need to land the drone at the third circle. So first I'm going to move the drone left side. So I'm going to type drone dot move left, this function. And I want to move this drone nearly 230 centimeter at left side. Then I'm going to move this drone forward 220 centimeter. So I will type drone dot move forward. Here I'm going to type 220 centimeter. Now let's save the file and save is it work properly or not. Is our drone travel over this circle or not? So after save that file, I'm going to click the start button. So after click the start button, as you can see, connect to the drone. Then I'm going to silence this drone sound. I don't want drone sound. And then it move left side, and it move 230 centimeter at left. And you can notice it in our minimap. Then it move forward. So it fly over this first circle. So it matches the condition. Then after move to 220 centimeter, it land the drone. Now we need to move this drone at right side again. So to do that, I'm going to type drone dot right side, right, move right. And here I'm going to pass a value. From this point, I'm going to move over this circle, and I want to bring this drone up to this distance. So nearly I'm going to pass 470 centimeter. And then I'm going to move forward again to land the drone to this circle. I already made the calculation before I start the project, because I don't want to take you too much time to make the calculations, so I already resolve it. So type drone dot move forward, and this time I'm going to move the drone 80 centimeter. I think it will match the condition. So let's save the file and run the code and wait and see is it fly over all the circle and land to the third circle or not. So I hit the run button. After connected to this drone, first it gain height up to 1 meter, then it's move at left side to 30 centimeter. Don't worry, I will fast forward the process. Then it move forward 220 centimeter. After reach 220 centimeter, it move 470 centimeter at right side. So it fly over the second circle. Then after reach 470 centimeter, it's move forward again and land to this circle. Good to see you back, friends. In this lesson, we are going to complete the level 3. In our previous tutorial, we completed level 1 and level 2. For that, basically we pre-program the drone and achieve the level. But in that tutorial, I am going to use keyboard control. We are going to manually achieve the level. So let's jump into the computer screen. So as you can see side by side, I open my simulator and Visual Studio Code Editor. And here you can see we already created a Python file main.py and keyboardcontrol.py. We learned about keyboard control earlier in our tutorials. So I'm not going to explain it here how it's work. Just I'm going to run the main file and I'm going to complete the level 3. So let's start the level 3. So I'm going to click the start button. After click the start button, you can start flying. At first we need to hover the drone to the first target, then we need to land the drone to the next target. So here I'm going to run the code in my terminal and we need to wait for connect to the drone. So as you can see, my drone is connected and it gained the altitude. Then I mute the drone sound. After that, I'm going to move right side, left side. Then after I move left side, I am going to move forward. And if I move forward, as you can see, it achieved the goal. Now I'm going to move this drone right side. After move this drone right side, then I'm going to move this drone backward using back arrow. After that, we need to reduce the drone altitude. For that, I'm going to press S. If I press S in my keyboard, then it's going to reduce the altitude of this drone. After that, again I'm going to reduce the altitude little bit and we need to hover my drone above this second target. So we are now above the second target. Now if I press L in my keyboard, it's going to land the drone over the circle. That's it. So we successfully complete our task. This is happen easily because here we use keyboard control. If we do not use keyboard control, then it is very difficult to pre-program the drone to achieve the right position. So this is it for this tutorial. Thanks for watching this video. At the next tutorial, we are going to learn how we can capture image from our drone. So stay tuned for our next tutorial. Hey, before we start our practical journey, this course is part of Drone Programming with Python using PySimverse Simulator. If you want to learn drone programming in very organized way and if you want to access the source file, then you can enroll the course. And time to time, I am going to update the new missions on this course. And remember, you don't need to pay high price to enroll the course. I will provide the link at my description. It is the fresh new course on Udemy. So don't forget to check out this course for once. So let's start our journey. Hello guys, good to see you back. Once again, I am back with a new tutorial related drone programming. And today in this tutorial, we are going to learn how we can get live video stream from our drone. To do that, we are going to use a new function called stream on. Also, we are going to use a new module to display the footage. We are going to use OpenCV. And if you are not familiar with OpenCV, otherwise computer vision, then you can check out my profile and you can learn it here. It is completely different topic, but today in this tutorial, I am going to use OpenCV to display the video footage, which we get from the drone. So let's back to the Visual Studio Code Editor. So as you can see side by side, I open my Visual Studio Code Editor and my simulator. And here I am going to open Garage mission. It is free play mission. So I start that mission. And then I'm going to mute the drone sound. I don't need it. Now, as I told you earlier, we are going to use OpenCV for this project. Then just you need to open your Windows PowerShell and here you need to type pip install OpenCV-Python, and then you need to hit enter. After hit enter, as you can see, requirement already satisfied, but you need to complete your download process. I already installed this module in my system and I continuously work on it. That's why I don't need to install it again. But you need to complete your download process if you do not install it. It is necessary. Then back to the Visual Studio Code. At first, we need to import the important modules. For that, here I'm going to type from PySimverse import drone. Also, I'm going to import time. With that, we need to import OpenCV. And to import OpenCV, we need to type import CV2. That's it. After that, we need to create a drone object. So, drone variable initialize with drone class and it's create an object. Next, I'm going to connect to the drone. So, to connect to the drone, we need to use drone.connect function and I print a statement drone connected. Then, I'm going to use little delay. So, for that, here I'm going to type time.sleep method and I'm going to wait for 1 second. Then comes the most important part of our video. We need to start the video stream. For that, we need to use a method called streamOn method. So here I'm going to type drone.streamOn and I print a statement in my terminal, video stream started. After that, we need to provide little delay. So here I'm going to type time.sleep method and I'm going to add delay for 2 seconds. This delay gives stream time to initialize. Then we need to take off the drone. So here I'm going to use drone.takeoff function and I print this statement drone takeoff successful. After that, I'm going to start the while loop. While loop to read the frame continuously. So I'm going to type while true inside this while loop, and inside this while loop we need to use a function called getFrame, drone.getFrame. So I'm going to type drone.getFrame. It is pretty similar with OpenCV read method. This function going to return total 2 results, the frame itself and a boolean value. If there is a frame, it's going to pass true, otherwise it's going to pass false. Also it returns the frame. And to store it in a variable, I'm going to define total 2 variables. Our first variable going to store the frame itself, and the second variable is success going to store the boolean value. Now here I'm going to set a if condition, and in my if condition I'm going to type it if not is success, then I want to continue this while loop, so I'm type continue. Now the question is, what is the meaning of that? It skip it when frame is not available. If frame is not available, if it's written false, then I want to skip the loop. That's why I use that condition. Next, we need to show the video stream from the drone feed, from the drone camera. For that, I'm going to use a method called IamShow, which is from CV2, OpenCV. So here we type cv2.imshow and our window name is drone video stream. And I want to display the frame itself, the frame we get from this drone camera. So I pass frame here. Next, we need to read keyboard input and we need to store it in a variable. For that, I'm going to define a variable key equal to cv2.waitKey method, and I'm going to wait for 1 millisecond. And I use this code, this SI code. And this code, &space 0xFF, ensure that the correct key code is extracted across different operating systems. You can use various operating systems such as Linux, Windows, Mac OS. So whatever operating system you use, if you press any key, we need to extract the correct key code. And the value will store in that variable called key. And next I'm going to set a if condition. If key equal to ORDL, in that case, if we press L in our keyboard, in that case I want to land the drone. With that, I'm going to set another command, some type or key equal to ORDL, capital L. So if user press small l, otherwise if user press capital L, in that case, I want to land the drone. So here I'm going to type print landing. Then drone.land function, drone.land, and I break the loop. Then after that, we need to destroy all the window. It is necessary if we use OpenCV. So outside the while loop, here I'm going to type cv2 dot destroy all windows, and I'm going to save that file. Now let's save the file and run the code in my terminal and see is it provide the cam footage from the drone or not. So after hit the play button, we need to wait for some time to start the webcam. As you can see, it start my webcam and video stream started, and then as you can see, it open a window from CV2, OpenCV, and our window name is drone video stream, and at that window you can see the live video footage which we get from the drone. This video feed is transferred by the drone camera. So this is how we can get video feed from our drone using stream on function. And using OpenCV, we can display in a window, in a separate window. And if we press L command in my keyboard, after select the window, if I press L, you can press capital L, also you can press small l, because here we set the condition for that. Here you can see we set it for small letter, also we set it for capital letter. So if we press L in my keyboard, instantly it's going to land the drone and automatically it close the window because we use cv2.destroy windows function. So in that tutorial, we are basically focusing on how to get video feed from our drone camera and how we can display it. At the next part of this tutorial, we are going to create a program that going to capture the footage, that going to capture a still camera footage and store it in our directory. Also, we are going to use keyboard control with that. So we can manually move our drone anywhere and we can take live footage. So don't miss that tutorial and stay tuned for our next video. Hello guys, good to see you back. Before we start our next mission, we need to learn how we can take images from our drone camera and save the image in our current working directory. So let's jump into the Visual Studio Code editor and start coding. How can we do that? So as you can see, I am in my Visual Studio Code editor and I open my previous files such as main.py file and keyboard control py file. Here we are going to integration image capturing with keyboard control. For that, I am going to use the exact main file. So in that tutorial, we are going to learn how we can take images from our drone camera and how we can save it in our current working directory. In our previous tutorial, we learned how to start drone camera and display the drone camera footage in an window with the help of OpenCV. But we do not apply any keyboard control, so we cannot move our drone in that program. But in this tutorial, we are going to apply keyboard control. Also, we are going to store the drone camera image in a directory. So let's get started. Just we need to working on main file. We don't need to working on keyboard control file. So I'm going to import our first module that we need to display the footage, which is CV2. So here I'm going to type import CV2. This module is used for computer vision, and with the help of this module we are going to display the drone footage in a window. Then I'm going to import another module. It's an inbuilt module and its name is OS module. So I'm going to type import OS. With the help of this module, we can access our directory. We can create folder, we can create file, we can pick any file, whatever. Then also we need time module. So I import time. With time, I'm going to import another important module, which is date time. So from date time, import date time. Now the question is why we need this date time module? Because we are going to create timestamp for the image file name. We are going to rename our image with exact time. That's why we need that. And finally, from keyboard control, we import getKeyInput method, this function. And you know that using that function, we can control our drone. Next, here we need to create a image save folder. So I'm going to type a comment. At that section, we are going to create a image save folder. We need to create a folder where captured drone images will be stored. For that, I'm going to define a variable, and our variable name is save underscore directory, otherwise dir, equal to capture images. So this is our directory name, I mean the folder name. Next, we need to create the folder if the folder doesn't exist in my directory. So here I'm going to use a function called makeDirs. So here I'm going to type os.makeDirs, make directories. So if I press tab, as you can see here we use that function os.makeDirs, and inside the round braces, first we need to provide the path, the folder name, and it's going to create that folder. And then we pass another parameter. In our first parameter, we need to pass the directory name, in our case save dir, and in our second parameter we need to pass a boolean value. Here I pass exist underscore OK true. It's going to prevent an error if the directory is exist. Then at the next section, we create the drone object. We already created in our earlier tutorial. First we create the drone object, then we connect to the drone, then I print a success message, drone connected. After that, after connect to the drone, at that section we take off the drone. Now then comes the most important part, where we are going to start the streaming. So I'm going to define another section for that, where we are going to start video streaming. And here I am going to use a function drone.streamOn. Using this function, we can turn on the drone camera, and then I am going to print some statement such as video stream started. After that, press C to capture image. If you want to capture image from your drone, then press C. Then press L to land the drone. After that, I'm going to define a variable, and our variable name is image count. Basically, I'm going to initialize this variable with 0, because over the time, after take pictures, we need to increase the value and we need to increase the count, because also we need to print how many pictures we take from our drone, and we need to print it in our terminal. That's why here I initialize the value, and I initialize the value with 0. And then we start the while loop, and as you can see at that section, we handle the keyboard control part. So I'm not going to touch anything here. Then after complete that section, after send the RC control values, I'm going to remove this print statement, also the time.sleep method. For now, I'm going to remove this one, and here I'm going to define another single line comment. We need at that section we are going to get the frames from the drone camera. So I type a single line comment get video frame. Then inside this while loop, we need to run a function, and here I'm going to type, and our function name is getFrame. And as you know, this function going to return total 2 value, frame itself and the boolean value. So I type frame and val equal to drone.getFrame method. Then we need to set an if condition, and you can run if condition on anything. You can run if condition on frame, also the value. So I'm going to run on value. If val is not none, then inside this if condition, here I'm going to type cv2.imshow method. I'm going to type cv2.imshow method, imshow. Then inside the round braces, I'm going to set the window name inside the double quotes drone camera, and I'm going to display the frame. So it's going to open a window using OpenCV and display the camera feed on this frame. So this is the first part of this tutorial. At the next part of this tutorial, we are going to be working on OpenCV keys. So stay tuned for the next part. Next, we need to work on OpenCV keys. With the help of keys, we are going to save the picture in our directory. So at first, we need to detect the keyboard press in OpenCV window. So here I'm going to type I'm going to type key equal to cv2.waitKey method, and I'm going to wait for 1 millisecond, and I use that code and 0xff. And as I told you earlier, this code ensures the key code works correctly across systems. After that, we need to capture and save the image. For that, I'm going to set an if condition. So here I'm going to type if key equal to ord, if we press C in our keyboard and val is not none, then inside this if condition, here we need to create the timestamp. So I'm going to type timestamp equal to, and for the timestamp I'm going to use datetime.now function, datetime.now dot strf time, and inside the round braces I'm going to set, first I'm going to pass the year, then I'm going to pass the month, then day, then I use underscore sign. After that, after underscore, I'm going to pass the hour, minute and second. So it's going to save the image according to the current date and time and month. So I just press tab and I use the suggested code by AI. And we get the timestamp from datetime function. And using datetime.now, we can get the current date and time. Next, we need to create the file name. For the file name, I'm going to use that timestamp. And here I'm going to define a variable called file name equal to os dot path dot join function, join. And inside the round braces, as first parameter, I'm going to pass the save directory where I'm going to save the image. Then here I'm going to use a f string, and then here I'm going to use f string. So I'm going to use the code suggested by our AI, and our image name going to start with drone image, and then it's going to print the exact timestamp. First it's going to print the year such as 2026, then it's going to print the month such as 06, and it's going to print the current date. Today is 14th June, so it's going to print 14th, then underscore, then it's going to print the current hour, minute and second. After that, we pass the extension of the image, which is .jpg. Now we have the file name, also we have the frame. So to create that image, I'm going to use cv2.write method. I am right. Then inside the round braces, I'm going to provide the file name and the frame. And to calculate the value, how many frames we capture from the drone, and here I'm going to increment the image count variable. So I'm going to type image count plus equal to 1. So every time it's going to increment the value with 1. After that, I'm going to print a statement. So I'm going to type print, and I'm going to use f string, and here I type image captured, and I'm going to print the file name. So whenever we press C in our keyboard, it's going to execute this code, this portion of the code, and capture the image and store the image in that folder. Else if key equal to key equal to, if we press Q in our keyboard, some type ORD inside the round braces, if we press Q in our keyboard, then I want to quit the program. I want to land the drone. So here I'm going to print quitting, and then I break the loop. Otherwise you can print landing drone. It's up to you. This is going to stop the program when Q is pressed. The loop exit and the drone lands safely. Then outside the elif condition, I am going to add little delay. Here I am going to use time.sleep method, and I'm going to add 0.05 second. Basically, this is going to run the loop approximately every 50 millisecond. And the benefit of using this delay is it's going to reduce CPU usage and prevent sending commands too rapidly. And then we need to handle the emergency exit. I'm not going to touch anything here. After that, we are going to jump into the finally block. Then after land the drone and the delay, I'm going to use another try block try. Here I'm going to turn off the drone stream. So I'm going to type drone dot stream of function. Except here I'm going to type pass. That's it. Now we work with OpenCV. So we need to destroy all the windows. It is necessary. So I'm going to type cv2 dot destroy all windows. Then I'm going to print how many image we capture at a time from the drone. For that, I'm going to type a print statement, print inside the round braces. Here I'm going to use f string and total image captured, and I'm going to pass inside the curly braces. I'm going to pass this variable image count. So how many pictures we take from our drone at a time, it's going to return in our terminal after quitting the program. And I'm going to save that file. That's it. So this is it. And we don't need to change anything in our keyboard control.py file. We don't need to touch the file. So let's save the file. And I'm going to run the code in my terminal. But before, we need to turn on this simulator. So let's do it. And now you can see side by side, I open my Visual Studio Code Editor and Drone Simulator application. And for now, in my current working directory, we don't have any folder. And with that, I am going to open free play mission to check our code working properly or not. So I start free play mission. And from here, I am going to click on garage option. And then I am going to mute the drone propeller sound. I don't need it. After that, I'm going to run the code, the main.py file in my terminal. So I hit the run button. After I hit the run button, we need to wait for some time to connect the drone camera. So it connected successfully and our drone take flight. It gained the altitude. Then you can see an window. And this is the window created by OpenCV. In that window, you can see the drone camera feed, live drone camera feed. Now, I am going to move the drone. So, if I move the drone forward, as you can see, after changing drone position, also, according to the perspective, it changed the stream footage. It is work as a real drone camera. We can gain altitude because here we apply keyboard control. Now I want to take a picture of this ceiling fan. So I gain altitude and I want to take the picture. To take the picture of this ceiling fan, here we need to select this window and we need to press C in our keyboard. After press C, as you can see, it take a picture. Now, if I open my directory, you can notice in my current working directory, it's create a folder capture images. Because if this folder is not exist, our code going to create that. Now, if I open this folder, here you can see the image, drone underscore image, and our image saved with timestamp. This is our current date and time, 2026-06-15 underscore, then it print hour, minute and second, 10:40:51. At that timestamp, we take the image. That's why it saved the timestamp at image name. So if I open that image, here you can see the result. You can see it saved the exact image we take from the drone. So this is how you can take image from the drone. Not only that, if you want to take more pictures, suppose now I want to move the drone. Near to the blue drum. I want to take this drum picture. So I want to rotate the drone at left side. Then we need to reduce the altitude of our drone. Then I'm going to move little bit right side and reduce the altitude, and then again I'm going to select this window and press C in my keyboard. Again it's going to take another picture and store it in that directory, captured images. Now after take two picture of the drum, so I'm going to press C and C again, I want to land the drone. So I'm going to press L command, and it's going to land the drone. And then here you can see total image captured 4. Drone lands successfully. It print this message, this print statement in my terminal, because here in our finally block we print this 2 statement. Here we print image count, also we print this success message. Drone landed successfully. At the next part of this tutorial we are going to start image capture mission. At that mission we have total 2 levels. And to complete the levels, we need to fly drone to targets, capture snapshot, and complete photo mission. And then at level 2, we need to capture multiple photos quickly. Hey, before we start our practical journey, this course is part of drone programming with Python using PySimverse Simulator. If you want to learn drone programming in very organized way, and if you want to access the source file, then you can enroll the course. And time to time, I am going to update the new missions on this course. And remember, you don't need to pay high price to enroll the course. I will provide the link at my description. It is the fresh new course on Udemy. So don't forget to check out this course for once. So let's start our journey. Hello guys, good to see you back. Once again, I am back with a new tutorial, and in that tutorial, I am going to complete mission 3. I want to say this mission, image capture. And to complete the mission, here I open my previous file, such as keyboard control to control the keyboard, and here I open my main file and I rename it drone_camera because it is particularly used for camera control. That's why I rename this file, and everything remains same. I don't change anything. Now let's open the image capture mission. So I'm going to click start button. And here we have total 2 levels. This is our first level. We need to fly drone to target and capture snapshot and complete photo mission. So it is the easy one. So here I am going to click start button. Now I am going to run the code in my terminal. So here I am going to press the run button. And we need to wait for some time to connect to the drone. And I am going to reduce the drone sound, the propeller sound. I don't need it. Now, after connect successfully, as you can see, here it open a window with the help of OpenCV. And you can see the drone camera feed in this window. And now we need to move this drone close to the circle. So first I'm going to press up arrow button. And it's going to move the drone closer to this circle. Then I move left little bit. After that I'm going to gain altitude using W key in our keyboard. Then I'm going to change the drone direction. I'm going to rotate it at right side. So I press D in my keyboard. Then I move the drone a little bit closer, and we need to move the drone close to this ring. And after close to the rings, as you can see, press Z to take snapshot. So here I'm going to press Z in my keyboard, and it complete the mission. To complete the mission, we don't need to take real image and we don't need to save it in our current working directory. But in my previous tutorial, I show you how you can do that. Because in real scenario, we need to take picture and we need to save it in my current working directory. That's why in our earlier tutorials, I show you how we can do that. Now, after complete this mission, this level, I am back to the menu section. Here, I am going to start level 2. And then I am going to close this terminal. I don't need it. Now, at the next level, we need to capture all the photos quickly for maximum star rating. But we are not going to do it quickly. Just we need to complete the level. So here I am going to start the level 2 and I'm going to run the code in my terminal. Now after connected successfully, as you can see, it's going to fly the drone. Also, it's going to open a window where we show the camera feed. Now let's back to this main window, and first I'm going to move the drone forward, then left side little bit, Again, I'm going to move forward. Then I'm going to gain altitude. And this drone camera feed help us to guide the drone properly. Then I move forward, and after move forward, I'm going to press Z. Then I'm going to turn the drone at left side. And here we need to move the drone to the next room. And for better view, for front view, you can see the front view in your drone camera feed to guide the drone. Press Z to capture the image. I'm going to reduce the altitude of this drone. Then I'm going to turn the drone at left side. Now we need to move the drone to the next room. Oops, I crashed my drone. Then I rerun this code and play the game again. And this time we need to gain the altitude. We need to come closer to this ring and press Z to take the snapshot. And we complete our level. Now remember, at the same time, if you press C command in your keyboard, it's going to take the picture and store it in current working directory. So if I press C and back to the directory, now you can see in our captured image folder we have an image of the drone. This image, the image we take using OpenCV. So this is how we complete our 2 mission easily. And from the next tutorial, we are going to working on hand gesture, where we are going to learn how we can control our drone with our hand. And then we are going to start this mission, level 1 and level 2. So this is it for this tutorial. Thanks for watching this video. Stay tuned for our next tutorial. At our next mission, we need to control our drone by our hand gesture. But before we need to understand how we can use computer vision to detect our hand. How we can use pre-trained AI model to detect our hand. To detect the hand and recognize the hand gesture, we need to work with OpenCV MediaPipe Task API model. MediaPipe Task API provide a pre-trained model that is used to detect faces, facial recognition, body posture, hand detection, etc. And by the help of this API, we can detect the hand and we can apply the hand gesture to control the drone. We already learned about OpenCV in our previous tutorials. We know how we can open a window with the help of OpenCV and display the camera feed. Also, we learned how we can take drone images from the camera with the help of OpenCV. But in this tutorial, I'm going to show you how we can detect the hand. For that, we need to jump into the computer screen. As you can see, here I open Windows PowerShell. In our previous tutorial, we download OpenCV module in our local system. OpenCV used for computer vision. But with OpenCV, we need to install another module. And our module name is MediaPipe. So to download the MediaPipe module, just type pip install MediaPipe. And I'm going to hit enter. After hit enter, as you can see, requirement already satisfied because I already downloaded it. But you need to complete the download process. It is very important. We use the MediaPipe module because it provides pre-trained AI models and tools that can detect and track objects such as hand, faces, body pose, and gesture in real time without having to train your own machine learning model. And it is very useful for hand detection and tracking, face detection and face mesh, pose estimation, real-time performance, and very easy to use. Now let's try to understand how MediaPipe read our hand. MediaPipe divide our hand into 21 landmark points. It is cut from the wrist joint. In every joint in our hand, MediaPipe assign a new landmark number, such as for thumb joint, it assign 1, and for the thumb finger tip, it assign landmark number 4. This is our index finger, and for index finger tip, it assign landmark number 8, and for index finger joint, it assign landmark number 5. This is how it assigns all the landmark number for our joints, such as 04 wrist, 14 thumb CMC, 24 thumb MCP, 34 thumb IP, and 44 thumb tip. This is how it reads all the joints. So whenever we make any gesture in our hand, we need to change the joint position, and it reads that position. We call all the points landmark. In our project, particularly we are focusing on landmark number 0. Because our project is not so complicated, just we need to move our drone left and right with our hand, so just we need to target landmark number 0, and it is the wrist joint. Using that, we can identify the position of our hand. Is it left side or right side? Next, we need to download a model. We need to download hand landmark model. It is provided by Google. Yes, MediaPipe was created and maintained by Google. That's why it is so efficient. And it is an open source framework. Now, we need to download this file, handlandmarker.task file. And to download this module, just search handlandmarker.task, and it will provide the link, and you need to click on this first link, hand landmarker detection guide. If you click on this, it will redirect to this link, and from here you can understand everything about task API, MediaPipe solution model, etc. I'm not going to deep dive into it. I just want to focus on our project requirement. For that, after scroll down a little bit, you can see we are working on Python programming language. For that, you need to click on this guide link, and it will redirect to this page. And here you can see hand landmarker example code. Click on this link, and from here you can download this file, handlandmarker.task file. Just you need to click this link, press Ctrl and click. It's going to download this file in your download folder. It is just 7.5 MB, and you need that file. You need that task file. It is the pre-trained model. And now you need to open your download folder, and you need to move that file in your current working directory, where you are going to create the Python files. Now what we are going to do basically in that tutorial. Basically, with the help of OpenCV, we are going to open our webcam, and we are going to show the webcam footage in that window. This is our window. Then we need to divide our window into 3 sections: left zone, dead zone, and right zone. After that, we need to track our hand wrist joint. So this is our wrist joint, and as I told you earlier, our wrist joint landmark point is 0. We need to track only this green dot. Now in front of camera, if I move my hand to the right portion of this window, then it's going to move the drone right side. And if I move the hand to the left side of the window, then it's going to move the drone left side. And if I move my hand between these two area, I mean the dead zone, then in that case it's not going to do anything. It's not going to move our drone, because here we declare it is our dead zone area. So from the next tutorial, we are going to start the actual project. But in our first tutorial, I'm going to show you how we can read our hand with the help of OpenCV and Task API. But there is another method. You can use old solution function provided by MediaPipe. In that case, you don't need to use Task API. But MediaPipe stops support solution function. But Task API is updated, faster, and newer. That's why we need to work on Task API. If you are not familiar with OpenCV and very enthusiast to learn computer vision, in that case, you can check out my profile. I create a bestseller course on OpenCV in Udemy. So if you are interested to learn computer vision, you can check out this. So this is it for this tutorial. From the next tutorial, we are going to start the practical. So finally, I am in my Visual Studio Code editor, and I already created a Python file hand_gesture.py. With that, I move handlandmarker.task file in my current working directory. So at first, I'm going to import the necessary module. And first, I'm going to import CV2. So I type import CV2. As you know, with this module, we can access webcam, drawing shapes, displaying images, etc. After that, we need to import MediaPipe, Google's machine learning framework for computer vision task. I want to say which I download earlier, the module we download earlier, and which is MediaPipe. So I'm going to type import MediaPipe as MP. And we are working with task API, so we need to import Python from MediaPipe task file. So here I'm going to type from mediapipe.task import Python. Then from MediaPipe task Python, we need to import vision. So here I'm going to type from mediapipe.task.python, I'm going to import vision. Using vision, we can perform hand detection, face detection, pose detection, etc. Next, we need to set up the MediaPipe hand landmarker. So here I want to define a comment. I want to make our code very clean and organized, that's why I use that comments. At that section, we need to load the train hand detection model. I want to say the task file handlandmarker.task. So here I'm going to define a variable called base option. Base option equal to python.base option. From this module from Python, here I call base option. And then inside the round braces we set model asset path, which is our file handlandmarker.task. As I told you, this task file contains the machine learning module. After that, we need to create configuration setting for hand detector. We need to set the parameters such as number of hand, base option, running mode, etc. So here I'm going to define a variable called option. Option equal to vision.handLandMarker option, and inside the round braces we need to pass base option. Base option equal to our variable base option. Then I'm going to define number of hand. Here I'm going to allow at a time number of hands 1. So it's going to detect one hand at a time. If we show two hand, it's going to detect the first one. It's not going to detect both the hand at a time because we mentioned number of hand 1. Then we need to define running mode. Running mode equal to vision.runningmode.video. Using base option parameter, we load the handlandmarker.task file. We are going to use that. And number of hand, define number of hands. And using running mode, we can define MediaPipe that we are going to input a continuous video stream because we are going to take input from webcam. That's why it is a continuous video stream. And we mentioned that here. This running mode come with total 3 value: image, video, and live stream. And in that case, we need to use video. After that, we need to create the actual hand landmarker object, and this object will perform hand detection. For that, I'm going to define a variable called hand landmarker equal to vision.handlandmarker.create underscore from underscore option, and here I'm going to pass inside the round braces I'm going to pass this parameter option. So here we create an object, and our object name is hand landmarker. Now let's open the webcam. But before, I'm going to type a comment. Here I'm going to type a single line comment. Open webcam. And then I'm going to open the webcam. For that, I'm going to define a variable capture, cap, equal to cv2.video capture method. And inside the round braces, I pass 0 because we need to open the default webcam. That's why I pass 0. If you have multiple camera in your system, then you can change the number. But for the default camera, you need to use 0. Then I'm going to set an if condition to prevent the error. So here I'm going to type if not cap dot is opened. If it is not opened, then print unable to open webcam. Otherwise, exit this if condition. This condition going to check whether the webcam opens successfully or not. And if it is not successful, then it's going to throw this error message in our terminal. Unable to open webcam. Instantly it's going to stop the program. It's going to exit the program. Next, I'm going to define a timestamp variable. Yes, if we work with MediaPipe video mode, then timestamp is required. So here I'm going to type timestamp initialize with 0. And this value increase with every frames when we run while loop. After defining the timestamp, I'm going to start the while loop to read the frame continuously. So I'm going to type while true, then inside the while loop, I'm going to set an if condition. Then inside this while loop, I'm going to read the frame. So here I'm going to use cap.read method, and as you know, this method going to return total two value, frame itself and the success message. So to type success comma frame equal to cap.read method. Frame going to save the exact frame value and success going to store the boolean value. If there is a frame, then it's going to return true. If there is not frame, then it's going to return false. Then inside it, I'm going to set an if condition. If not success, I'm going to break the loop. Break. It's going to stop the loop if frame capture fail. After that, after set the condition, I'm going to mirror the frame. Basically, I'm going to flip the frame horizontally. I'm going to flip the image horizontally. For that, here I'm going to type frame equal to cv2.flip method, and inside the run braces, I'm going to flip the frame and I pass the code. And code is 1. If I pass 1 here, it's going to flip the frame horizontally. Its fill we are looking like into mirror. That's why I flip this one. After that, we need to convert the color channel. We need to convert BGR to RGB. By default, OpenCV read frame in BGR mode. But when we work with MediaPipe, we need to convert it into RGB. So here I'm going to define RGB equal to cv2.cvt color. Using cvt color, we can change the frame color method. And then we pass the frame itself and we change the value. We are going to apply BGR to RGB color mode. After that, we need to convert the NumPy image into MediaPipe image object. Yes, now it is a NumPy image, and we need to convert it into MediaPipe image. For that, here I'm going to define an object, and our object name is MP image. MP image stands for MediaPipe image. MP image equal to, from MediaPipe, I want to use this function image, and inside the round braces, as the first parameter, I'm going to pass image format, and then we pass the data RGB. After that, we need to run the hand detection on current frame. For that, here I'm going to define a variable called results. Result equal to hand landmarker dot detect for video, and inside the round braces in that function, I'm going to pass MediaPipe image and timestamp. And also we need to increment this timestamp for the next frame. So here I'm going to type timestamp plus equal to 1. I want to increment the value with 1 frame. Now this variable result contain the hand landmarks. Also it's going to store confidence scope. Next we need to grab the frame shape. The frame shape we create for webcam. And to grab the frame shape, here we need to use a method called frame.shape, and this method going to return total 3 result: height, width and color channel. And to save height and width, I'm going to define height and width, and for the color channel, here I use underscore sign equal to frame.shape method, and I will set that file. And now after that, we need to detect the hand. For that, I'm going to type a single line comment. At that section, I'm going to detect the hand. So here I'm going to set a if condition to check if hand is exist or not. So type if results.handLandmark, if hand landmark exists, then inside this if condition I want to access landmark number 0. So type landmarks equal to result.handLandmarks. Inside the square braces, here I pass the landmark number, which is 0. And as I show you earlier, hand landmark 0 represent wrist joint, this wrist joint. So we need to identify it and we need to draw a circle above it. As I told you earlier, each of the hand contain 21 landmark points, and it starts from wrist joint 0. And we need to detect only this one. We don't need to detect all of it, and we don't need to draw a circle around it. We need to make our code clean and faster, so we need to focus on only the 0 landmark point number. So let's back to the code editor. This one represents wrist landmark. After that, we need to get the x-axis value of the wrist position. For that, I'm going to define a value wrist x equal to I'm going to use int function int because we need to convert it into integer. Then inside the round braces, from landmark I want to access wrist, so I pass 0, and from the wrist I want to extract the x-axis value, and then I multiply with width of this frame size, and it's going to return the x-axis position of the wrist point. Now the question is, what is going on here? What does that mean? MediaPipe return the landmarks into normal value, something between 0.0 to 1.0. It could be anything. Suppose our value is 0.5. Now I'm going to make it a comment. So here I'm going to type hash. Suppose it will return that value 0.5. This value is, the coordinate x-axis value is 0.5. Now if I multiply the value width of this frame, so our frame width is, suppose our frame width is 640 pixel, multiply with 640 pixel, then it's going to return the value. It's going to return the actual coordinate value of this x, which is 320 pixel x-axis coordinate, and that's the value we need. At the same way, we need to calculate the y-axis of this landmark point. So I pass tab here, and this time we need to multiply with height, and it's going to return the y-axis value. Suppose our frame height is this, and we multiply with 0.5, it's going to return the actual y-axis of this coordinate. And remember, it returned the value in pixel. Now we have the actual pixel position of our point, and so I'm going to draw a circle above it. So type cv2.circle method, this function. Then inside the round braces, first I'm going to pass the frame. Here I pass the frame, and then wrist x position, wrist y position. After that, here I define the radius of the circle, and our circle radius is 5. I'm going to make it 8. I want to make it larger. Then I use the color code. Here I use green color for that circle, and then I fill that circle with -1. If we pass this value -1, it's going to invert the circle. It's going to fill the circle with color. Otherwise, it's going to make just outer line. And I'm going to save that file. And now to draw the circle, I want to display the frame. So here I'm going to type a single line comment, and here I'm going to type display output, and below it I want to show the frame, and here I'm going to type cv2.im from method hand gesture recognition, and I want to display the frame. This is our window name for this frame, and then I want to quit the program if we press Q in our keyboard. So here I'm going to type the if condition, if cv2.wait key, and I'm going to wait for 1 millisecond, and 0xff equal to ordq. If we press Q, then I want to break the loop. That's it. Next, we need to clean up the window. So outside the while loop, I'm going to type another single line comment, clean up. At that section, I'm going to type cap.release method, cap.release, because if we capture any frame, also we need to release it. Then we need to destroy all the windows. This is going to close all the OpenCV windows. Now let's save the file and run the code in our terminal. So after save the file, I'm going to hit run button, and we need to wait for some time to start the webcam. Now to start the webcam, if I raise my hand, as you can see, it detects the wrist joint. This is my right hand and this is my wrist joint. You can see the spot on it. And at the same time, it detects only one hand wrist joint. And if I hide my right hand, now you can see the landmark point in my left hand. Because we mentioned at a time we are going to detect only one hand. Now using this wrist joint, at the next part of this tutorial, we are going to create the gesture. Basically, we are going to create the trackpad. So this is it for this tutorial. At the next part of this tutorial, we are going to create the area for the left, right and dead zone. So thank you very much for this tutorial. Stay tuned for the next part. So in our previous tutorial, we identify landmark number 0. Now we need to split our screen into 3 parts. We need to create left part, we need to create dead zone, and we need to create right part. If I move my hand left to the screen, then it's going to show left side. If I move my hand middle center of the screen, it's going to show dead zone. And if I move my hand right side of the screen, it's going to show right side. So this is exactly what we are going to create. We need that because using that we are going to control the drone left and right. So without talking too much, let's get started. So as you can see, we are in my Visual Studio Code editor. And now at first I'm going to define an area for dead zone width. For that, here before opening the webcam, I'm going to type a single line comment and I'm going to name it dead zone width. And at that section, I'm going to define the dead zone. And I'm going to define the dead zone area 60. Now let's jump into the while loop. So we are in the while loop. And here we are going to define the zone. So basically we are going to draw the zone area. So I'm going to define a single line comment, draw zone. And that section we are going to draw the zone. Here I'm going to create total 3 rectangles to define the zone, to separate the zone from each other. So I'm going to type cv2.rectangle. And at that function, in that rectangle function, we need to pass the frame. First, we need to pass the frame itself, some type frame. Then we need to define the first point or the starting point of the frame. And I want to start it from the left top corner. So I pass 0 pixel by 0 pixel. This is the starting point of our rectangle. We are going to, if it is our window size, we are going to start the rectangle from this left top corner. Next, we need to define the end point of the rectangle. Suppose this is if our starting point, I want to end the rectangle at that point. For that, we need to make some calculation. First, I'm going to divide with some type I'm going to divide width by 2. After divide width by 2, I'm going to minus dead zone from it, dead zone. Then after comma, for the y-axis, this is for the x-axis, and for the y-axis, I'm going to define the height of the frame. Some type height. After that, I'm going to define the color of the rectangle. So inside the curly braces, inside the round braces, I'm going to pass 0, 0, 255. Then after comma, I'm going to pass the width of this rectangle. Here I'm going to pass 2, and I'm going to save this file. I create that rectangle for the left side. Now save the file and run the code in our terminal and see is it create the rectangle successfully or not. So if I hit the run button and wait for some time to start the webcam. Now as you can see in our window, we create the rectangle left side of our window. This is the left side of our window. And this is the right part of our window. Between them, I'm going to create a dead zone. Now, we need to put a text in it. We need to define that it is the left side. So let's back to the code. So I'm going to press Q in our keyboard to quit the program, and let's back to the code. Next, we need to create another rectangle for dead zone. So I already create that. I already make the calculation where we are going to place the rectangle. So I'm going to paste the code. We place the rectangle in our frame, and this is our starting point. From where we are going to start our rectangle, and this is our end point. And this is the color code of our rectangle. And it is the width of this rectangle frame. Now, this one is for dead zone, and we need to create another rectangle for right side. Next, I'm going to create the third rectangle for the right zone. So I'm going to type cv2.rectangle, and I'm going to put the rectangle inside the frame. And then we define the starting position of this rectangle, then we define the end position of the rectangle. And our end position is width and height of this actual frame. Then we pass the color code and thickness. After that, we need to define the zone name. So first, I'm going to define the left zone. So to define the left zone, we need to use putText method. So type cv2 put text, and I'm going to put the text inside the frame. And next I'm going to define the text, and our text is left, and this is the starting position of our text. From x-axis 20, from y-axis 40, and we use font Hershey simplex text, and our font scale is 1, and this is our font color, and I want to set that 5. And at the same way I'm going to define the dead zone. For that, again I'm going to type cv2.putText, and I name it dead zone. Then I define the position of the dead zone, and here I make the calculation. Don't worry, I will explain the position later, how we can position the text correctly. And at last we need to put another text for right hand. So here I type put text, and I put it in a frame, then I name it right. Now let's save the file and run the code in our terminal and see is it properly work or not. So after run the code in our terminal, we need to wait for some time to start the webcam. And then you can see we define the zone perfectly, nearly perfectly. Left zone, dead zone, and right zone. This is our left zone area, this is our dead zone area, and this is our right zone area. This area is right zone. And now we are going to use that window as a trackpad, and we can control the drone wherever we move the hand. Suppose if I move our wrist to the right side, it's going to move the drone right side. And if I move to the left side, it's going to move the drone left side. And if I move my hand to the dead zone, then it's not going to move the drone anywhere. Then it's going to place the drone center of our window. So this is how we are going to control that drone. Now let's back to the code. Now you can see at that section we detect the hand using this if condition. Now inside that if condition, we need to use another if condition to zone detection. Here we detect the hand and we draw the landmark. Here we need to define the zone area. Here we need to define which zone is left, which zone is right, and which is the dead zone. Now at that section we extract the hand landmark, particularly landmark number 0. We have landmark number 0, x-axis coordinate and y-axis coordinate. Now according to the landmark position in a window, we need to define that position. We need to define is it left or right or dead zone. For that, I'm going to set an if condition here. So inside that if condition, I'm going to set another if condition. But before, I'm going to type a comment and zone detection. And here I type a comment zone detection. Then I'm going to set the if condition. And I'm going to type if wrist x less than width divided by 2 minus dead zone, then at that section I'm going to define the zone. I'm going to define it is left zone, and I said this color. Otherwise, else if wrist x position greater than width divided by 2 plus dead zone, in that case we need to mention that zone right zone, and I change the color. And in our else block, else I'm going to mention the remaining part dead zone. That's it. So whenever I move my hand any of the zone, such as if I move my hand to the left part, it's going to print left, and if I move my hand to the right part of our window, it's going to print right, and if I move my hand middle of the window, then it's going to print dead zone. And to print the value, I'm going to type a print statement, print. Inside the round braces, I want to print only the zone value. So I'm going to type zone. That's it. Now after print the zone value in my terminal, also I print the zone value with our landmark point, beside the landmark point. For that, we need to use put text method. So I'm going to type cv2.putText. Then inside the round braces, the first value I'm going to use where we are going to put the text in our frame. Then we need to define the text. What text we are going to print? In our case, the zone value. And according to the if condition, time to time, according to our hand position, it's going to change the zone value. If we move our hand left side, it's going to print left. Then if we move our hand to the right side, it's going to print right. And if we move our hand to the dead area, then it's going to print dead zone. And then I define the position of the text. With wrist x-axis value, we add 10 pixel, and from wrist y-axis value, we minus 10 pixel. So it's going to print the text beside it. And this is it. If I save that file and run the code in our terminal, let me show you. So I'm going to hit the run button. And we need to wait for some time to start the webcam. Now to start the webcam, if I raise my hand, now you can see it print a dead zone in our terminal. Now if I move my hand to the right side, it print right value in my terminal, right. And if I move my hand to the dead zone again it print dead zone. And if I move my hand, basically the wrist position of our hand to the left side, it print left value. So this is how our trackpad work. And using that value in our upcoming tutorial, I'm going to show you how we can control the drone. If I move my hand to the right side, it's going to move the drone right. If I move my hand to the left side, it's going to move my drone left side. So this is exactly what we are going to create. So this is it for this tutorial. Stay tuned for the next part of this tutorial. Hello guys, good to see you back. Once again, I'm back with a new tutorial. In our previous tutorial, we learned how we can detect the hand and how we can use our window as a trackpad. Basically, we are going to use the window as our controller. Using that window, we are going to send the RC control in our program. Basically, whenever I move my hand left or right side, I want to control the drone. And now in that tutorial, we are going to convert our hand detection model into a function, and that's going to return the RC value. So without wasting your time, let's back to the Visual Studio Code. So as you can see, we are in my Visual Studio Code editor, and we created that program in our previous tutorial. Now I am going to convert this program into a function that's going to send RC value, and we are going to use this value in our another Python file to control the drone. For that, first I am going to remove some unnecessary comment. I don't need that comment because I hope it is already clear for you which part is used for what purpose. So I'm going to remove these unnecessary comments, otherwise it's look very hazy. And I'm going to call the dead zone variable at that section after import the modules, and I'm going to remove it from here. And then we need to make some changes in our code. I'm going to move this timestamp variable upward. After I move it, after open the webcam. Now I'm going to remove the while loop. Now you might have question why I remove the while loop. Here I'm going to replace the while loop with a function, and then I'm going to return some value, some kind of RC value, and I'm going to use the while loop in our main file whenever we call the function. So let's back to the code. Here I'm going to replace the while loop with this function, def get hand RC, and I don't need that if condition anymore, so I remove that. And the first thing I'm going to do inside the while loop, I'm going to make timestamp variable global because we are going to use that function in another file, another Python file. That's why we need to make it global. So I make this variable global. Next, here I use the if condition. If not success, then I'm not going to break the loop because I don't have any loop in our function. So I'm going to return, and I want to return a value 0. That's it. Then everything remain as it is. Now everything remain as it is. So I scroll down a little bit, and we should point out in which point we need to make some changes. Then I jump into the hand detection part, and here we need to make some changes at that point. As you can see, at zone detection section, we pass a value. We define a zone, left, right, and dead zone. Now at that section, I'm going to remove color. I don't need that. And here, I'm going to add another value. Here, I'm going to define left, right value, which is going to use for RC control. So for the left hand, I'm going to pass minus 30 point. So I pass left right value minus 30, and I'm going to use the zone as label. Then for zone right, I'm going to pass for zone right, I'm going to pass left right value positive 30. Here I pass negative 30 to move the drone at left side. And here I pass positive 30 to move the drone at right side. And for the else part, here I'm going to define left right value 0 because it's a dead zone. And for the color I'm going to use green color. So I'm going to replace color value with green. In all the portion it's going to return the green color, and I don't need this print statement, so I remove that. Now let's scroll the page a little bit, and from here we need to remove the break statement. At first I'm going to show the simple hand gesture frame, then I remove the if condition. I don't need for now. Yes, I need that, but not that way. Here I just want to call wait key value, so I type cv2.wait key, simply that. And then this function, the main function, I want to say our function get hand rc going to return the left right value, just left right value. For left hand it's going to pass negative 30, for right hand it's going to pass positive 30, and for the dead zone it's going to pass 0, left right value 0. That's it. Not only that, I think also we need to make some changes in cleanup section. So here I'm going to define a function. So I'm going to type def, and our function name is close camera, and I'm going to call release and destroy all window in that function, in that close camera function, and I'm going to save this file hand gesture. So here we create a separate file for controller. It's going to pass only the control values as left right variable. Now we need to create main file where we are going to run the PySimverse drone. So for that I'm going to define a Python file main.py, and at first I'm going to import the drone class from PySimverse module. So here I type from PySimverse import drone. Then I'm going to import time module. So I'm going to type import time, and from hand gesture file we need to import these two functions, get hand rc and close camera. So here I'm going to use this suggested code by AI, so I'm going to press tab. Also we need to put it inside an round braces. After import the functions from the other file, hand gesture file, here I'm going to create the drone object. So I'm going to type drone equal to drone object. Then I'm going to connect to the drone. So I type drone.connect method, and then I print a success statement. So I'm going to print drone connected. After that we need to take off the drone. So here I'm going to type drone.takeoff, and also I'm going to print a success message in our terminal, print drone takeoff successful. And after take off the drone I want little pause. So here I'm going to use time.sleep method, and I'm going to take 2-second delay. Then I'm going to open the try block. So I'm going to type try. Inside the try block I'm going to start the while loop. So I'm going to type while true. Then inside this while loop, at first we need to call the function handgesture.py file. So I'm going to define a variable left underscore right equal to get hand rc, this function, and then I'm going to pass the rc control to our drone. So I'm going to type drone dot rc control, send rc control. Here we need to pass the left right value. First we need to pass the left right value, then up and down, then camera angle and stream on and other values. So for left and right I'm going to pass the variable left right, and for other values I'm going to set it 0. Here I just want to control the drone left and right, nothing else, simply that. Then I'm going to print a statement. Here I want to print the speed of the drone, left and right speed of the drone. So I'm going to type print, and then inside the round braces here I'm going to use f string, and I'm going to type left and right speed. Inside the curly braces I pass the value left and right. Then we need to jump into the exception block, except keyboard interrupt Then I want to print, here I want to print landing drone. Then in the finally block, so type finally, then inside the finally block, we need to handle the RC control again. So type drone dot send RC control. And this time I'm going to set all the value 0. Then I land the drone. Now after land the drone, also we need to close the webcam and destroy all the windows from OpenCV. For that, as you can see in our hand gesture file, here we create a function close camera. So this function going to release the cam and destroy all windows. So I call that function close camera. And at last I'm going to print a statement, print drone landed. That's it. And I'm going to save that file. Let's run the code in our terminal and see is it properly control our drone or not. But before, we need to open our application, our simulator. So as you can see here, I open my simulation application, and for testing purpose I am going to open free play mission. So first I'm going to turn off the sound of this free play mission. So I open that and I'm going to turn off the sound of this drone. Then I'm going to run the main.py file, and after run the code, we need to wait for some time. As you can see, after wait for some time, our drone successfully connected to our code and it start the propellers. Also it start gain altitude. And now you can see it open the trackpad in a window and already start moving our drone according to the hand position. But I am going to move this window right side of our screen. And you can notice that my hand is in dead zone. Now, whenever I move my hand to the left side, it moved the drone left side. And if I back to the dead zone again, then it stopped moving. Now, if I move my hand right side of our screen, it moved the drone right side. And also you can notice in our terminal, it print the left-right speed value. If I move my hand to the left side, then it print negative value. And if I move my hand to the right side, then it print left-right speed positive value. But at dead zone, it print left-right speed value only 0. And if I move my hand outside the frame, it's going to land the drone safely. It's going to quit the program. So if I remove the hand outside the control panel area, instantly it's going to close the program and destroy all the window and land the drone safely. So our program worked perfectly as it is I want. Now using that program and hand gesture, at the next tutorial, I'm going to complete the new mission, hand gesture. Here we have total 2 levels in that mission. And one by one, I'm going to complete all of these. Because of this 2 mission, we need to create this hand gesture control file. I hope now you understand. Hello guys, good to see you back. At that section, we are going to complete 3rd mission, hand gesture. In that mission, we have total 2 levels. If I click on the start button, as you can see, we have level 1 and level 2. At level 1, the drone hovers steadily while boxes came towards it. Use hand gesture to hit the boxes, and if you miss 3, and it's game over. So we need to use the hand gesture file. So as you can see at right side, here I open our hand gesture model, which I learned earlier how to create it and how to perform it. I am not going to explain it again, I just try to complete the level. So let's start level 1. Now at first I'm going to turn off the drone propeller sound, I don't need that. Then I'm going to jump into the main.py file and I'm going to hit the run button. After I hit the run button, we need to wait for some time to start the webcam. We need to wait quite a long time to start the webcam. And now you can see our program successfully connected to the drone and start the propeller. And after a couple of seconds, it turned on the hand gesture recognition window by the help of OpenCV. And we are going to use this window as a controller. Now, as you can see, my hand is in dead zone. And if I move my hand to the left side, it moves the drone left side. And if I move my hand to the right side, it moved the drone right side, and it completed the level successfully. And to close the program, if I remove my hand out of the frame, instantly it's going to break the loop. And as you can see, we complete our task within 21 seconds. So this is what we need to do in our first level. Now let's jump into the next level. Now I am going to complete the level 2. The drone hovers in place. Use hand gesture to move it to the left and right boxes one by one. So we need to move left and then we need to move right to hit the boxes. So let's start the level 2. And for that we are going to use the exactly same code. We are not going to change anything. After start flying, first I am going to reduce the propeller sound, I don't need that. Then I am going to run the main file. And after run the main file, we need to wait for some time to start the webcam. As you know, it takes time to start the webcam and establish the connection with the simulator. Now to establish the connection with the drone, it already started flying and move forward direction. You can see the upcoming boxes and we need to hit as much we can. So let's see how many I can hit. I already hit one at left side, then at right side hit another. And I continuously hit couple of boxes. And at the end, I hit total 11 boxes. And our game is over. So I complete the mission successfully. So this is it. Stay tuned for our next mission. Hello guys, good to see you back. Once again I am back with a new tutorial, and today in this tutorial I am going to show you how MediaPipe pose detection works. In our previous tutorials we learned how to detect hand and how to recognize hand landmarks. But in that tutorial we are going to recognize body structure with the help of OpenCV and MediaPipe Task API. Before our upcoming project, it is important to know how to detect body posture. So let's go to the computer screen and see how it's work. Let's try to understand how it's work. How machine learning programs read our body structure. At first, as you know, we need to capture the frame from our webcam. Otherwise, you can use pre-recorded video. Next, we need to use AI model that's going to process the frame. In our case, MediaPipe introduced total 3 AI model: light version, full version and heavy version. We are working with modern Task API, not old solution function. That's why we need to download task file. These are pre-trained models that recognize body pose structure. If we talk about the light version of poselandmarker.task file, if I talk about its characteristics, it is the fastest model, lowest CPU usage and lowest memory usage. Also, it provides lowest accuracy among the 3. It is best for real-time webcam application, drones, robots, gesture control, Raspberry Pi projects and old laptops. If you don't have powerful hardware, then you can use that model. And the advantages of use the light version is it processes high FPS, low latency, and runs smoothly on any low-end hardware. But also there are some disadvantages, such as less accuracy when person is far. Also it did not work properly when body is partially hidden. Next, it provides full version, pose landmarker _ full version. If I talk about its characteristics, it is provide balance speed and accuracy. Also it is the most commonly used model. It is best for general purpose pose tracking, fitness application, exercise counter, yoga detection, educational projects. If I talk about its advantages, it provides better landmark accuracy, still work in real time in most computers. Also good compromise between performance and quality disadvantages. But it is slightly slower than light version. Most of the time we use that, but not for drone project. Then comes the heavy model. It provides highest accuracy, largest model size, and highest usage of CPU and GPU. It is best for professional motion analysis, research object, biomechanics, sports analytics, precise body tracking. If I talk about its advantages, it provides most stable landmarks, better tracking of difficult pose, better depth estimation. Also, it comes with some disadvantages such as lower FPS, require more powerful hardware, and it is not ideal for low-end systems. That's why we do not use that. We do not use it project like drone controlling. And to download the models, just search Pose Landmarker Task Download. Then it provides the link, and that's the official link, Pose Landmarker Detection Guide. Open this one, and after that, as you know, we are working with Python programming language, so I'm going to select Python. After select Python, scroll down a little bit, and here it provides the models. It provides the MediaPipe Pose Landmarker Task models. And if you click on the model selection option, you can see all of these models such as Pose Landmarker Light, Full and Heavy. And according to your needs, you can download this model by clicking the link. After clicking the link, as you can see, it downloads the models in your system. It's up to you. In that tutorial, I would like to go with the two version, Light and Full. I'm going to test this two version. So you can download it and put it in your current working directory. Now look at the structure of the human figure. This is how MediaPipe model read our body structure. It divides the whole human figure into 33 landmarks. It starts from 0. 0 represents the nose. Then 1, 2, 3. 1 represent right eye inner, 2 represent right eye, 3 represent right eye outer. If I talk about the key points, it can detect nose, eyes, ears, shoulders, elbows, wrist, hip, knees, and ankles. It can detect whole human structure, body, joints. Now, as I told you earlier, MediaPipe Pose Landmarker create 33 different landmarks. In our previous tutorials, we already learned about hand landmarks. Hand landmark model detect 21 hand landmarks. But Pose Landmarker create 33 different landmarks. And every landmark number represent every part of our body. So, if we use 0, then it represent our nose. If we use 10, it represent mouth left. But for this particular tutorial, we need to create that skeleton structure in our frame. Also, we need to draw the landmark points. We need to understand this structure because in our upcoming projects, we are going to use that. So without talking too much, let's start the practical. So finally, we are in my Visual Studio Code editor. As you can see in my current working directory, I already create a Python file named body.py. Also, you can see in my current working directory, we have two task file, Pose Landmarker full.task file and Pose Landmarker light.task file. We have total 2 AI model. And if you would like to work with the most accurate version, in that case you can use Pose Landmarker heavy.task file. But for now it is good for us to work with full and light version. So without talking too much, let's start coding. First I'm going to import CV2. So here I'm going to type import CV2. As you know, we need CV2 to accessing webcam, processing image and displaying windows. Then after that, I'm going to import MediaPipe. I'm going to import MediaPipe as MP. It's going to import the MediaPipe library. It is used for AI-based landmark detection. Next we need to import MediaPipe Task API Python module. For that, here I'm going to type from MediaPipe.task, I want to import Python. It gives access to task-based model such as hand landmarker, pose landmarker, and face landmarker. In our previous tutorials, we learned about hand landmarker, but in that tutorial, we are going to learn pose landmarker. After that, we need to import vision. We need to import vision from MediaPipe task Python module. So here I'm going to type from MediaPipe.task.python. I'm going to import, here I import vision. Here we import vision related classes. Next, we need to import a new thing. We need to import a protocol buffer landmark structure from MediaPipe frameworks. So here we need to type from MediaPipe.framework.formats import landmark underscore pb2. Now the question is why we need that. It is needed because the task API return landmark in a format that OpenCV drawing utils cannot directly use. Using that, we can convert landmark into normalized landmark list so MediaPy can draw them. After that, we need to set up the pose landmark. For that, here we need to type base option equal to python.baseOption function from MediaPy. Python.baseOption class from MediaPy. Then inside the round braces, we need to define model asset path. And here I assign model asset path pose landmarker light.task file. This one. This model contains the trained neural network. And this model provides fast speed but low accuracy. Don't worry, next we will try with full version also. But for fastest result, I use light version. After that, we need to create post landmarker configuration. For that, here I'm going to type options equal to vision.post landmarker option, and inside the round braces, first I said base option, this base option, running mode vision.running mode.video because it tells MediaPy that frames come from a video stream. And as I told you earlier, there are three options: image, video, and live stream. But if you use webcam, you need to use video. Then number of pose we allowed. So at the same time, it's going to detect only one figure. If you have multiple figure in front of camera, then it's going to select the first one, the first figure. If you set it 5, then at the same time it's going to detect 5 people. And if you set 1, at a time it's going to detect 1 people. Then after that, we need to create the actual pose landmarker object. So I'm going to define a variable pose landmarker equal to vision.poseLandmarker.create from option. This class, this function. From vision module, here I call this variable pose landmarker and I run that function create from option. And inside the round braces, I pass option, the option we create earlier. And now it is become an actual object. And now our AI is ready. After that, we need to focus on drawing utils. Here, I'm going to load MediaPy drawing tool. For that, we need to type a variable. You can type any variable. In our case, I'm going to type mp underscore drawing equal to mp.solutionModule.drawing utils. This one used to draw circle, lines, and landmarks. After that, we need to load pose module. So I'm going to type mp pose MediaPy pose equal to mp.solution.pose. This pose module contains skeleton connections. Now at the next part, we are going to set up the camera. So at that section, I'm going to type a single line comment camera, and here I'm going to type cap equal to cv2.video capture method, and inside the round braces I want to start the default webcam, so I select 0. Also, we need to initialize timestamp with 0 because we are working with task API. That's why we need that. Basically, this variable going to store video timestamp. And we need that because MediaPy tracks motion across frames. Next, we are going to start the main loop. And you know the process. So, we need to type while true. After while true inside the while loop, here, we need to read the frame using read method, cat.read method. And as you know, this method return total 2 result, frame itself and a boolean value. In our case, I store it in a success variable. And then I'm going to set a if condition. If not success, then inside this if condition, I want to break the loop. Break. That's it. After that, I'm going to mirror the image. We need that. Next, we need to convert BGR to RGB. So here I'm going to type RGB equal to I'm going to use cv2.color method, and here I'm going to change the color of our frame. So I type, first I provide the frame, and then I use cv2.color BGR to RGB. By default, OpenCV read our frame in BGR color mode. But whenever we need to work with task API, otherwise MediaPy, in that case we need RGB color frame. Then after that, I'm going to create the MediaPy image object. So I define a variable mp image equal to mp.image. From media pipe, I call image. For media pipe, I import image. And inside the round braces, first to define image format equal to mp dot image format dot srgb. Then data equal to RGB. It is a specific image format. sRGB means standard RGB. And data equal to RGB, this variable mean here we passes RGB frame. So here we complete the media pipe image object. After that, we need to run pose detection. So here I'm going to type result equal to, we need to run a function and we call that function detect for video. And some type result equal to pose landmarker, result equal to pose landmarker object, and in that object I run that function called detect for video. And inside the round braces, in that function first we provide the input frame which is mp image, this variable, and also we need to pass timestamp. It is the current frame timestamp. Then also we need to increment the timestamp value. So here I'm going to type timestamp plus equal to 1. For every iteration of while loop, it's going to increment the value with 1. Next, I'm going to draw the skeleton of our body. So here I'm going to type draw skeleton a single line comment, and then I'm going to use if condition. Here I'm going to type if results dot pose landmarks, then inside this if condition I want to run a for loop. Here first we check if body was detected, then we loop through detected people. So I type a for loop for pose in results dot pose landmark, and as you know here we allow only one number of pose. That's why it's going to detect only 1 person at a time. Then inside the for loop I'm going to create a empty landmark list. So I'm going to type pose landmark photo equal to, inside the round braces, landmark underscore pb2. From this module I want to use this function normalize landmark list. Basically this is going to create an empty landmark list, and media pipe drawing tools require this format, otherwise it cannot draw the points, line, etc. Then inside this for loop we need to run another for loop through landmark points. So here I will type for landmark in pose, then inside this for loop, basically it iterates through all the body landmarks, and as you know it returned total 33 landmarks, 33 body landmark points. And you know each of the landmark return total 3 value: x-axis, y-axis and z-axis, horizontal coordinate, vertical coordinate and depth. So inside the for loop I'm going to type pose underscore landmark underscore photo dot landmark dot add method. Then inside the round braces, we need to extract all the value from the landmark, such as to extract the x value I type landmark dot x, to extract the y value I type landmark dot y, and to extract the z value here we access landmark dot z. And the last parameter is visibility. Visibility equal to landmark dot visibility. It is the confidence that landmark is visible, and it's set range between 0 to 1. Next, outside the for loop, we need to draw the landmarks. So I'm going to type mp underscore drawing dot draw landmarks. Then inside the round braces, we need to set the credentials, such as first I'm going to pass the frame where we are going to draw. Then we need to pass pose landmark photo. After that, I'm going to pass the connections, pose mp pose dot pose connections. Then we need to define a function. Here we need to define mp drawing dot drawing specs. Here I said thickness 2 and circle radius 3. Now what basically we done here? This function, this single function, is responsible for drawing the entire pose skeleton on the image. Let's background it argument by argument. First, in that function, in draw landmarks function, we pass frame. This is the image where the pose will be drawn. Then come pose landmark photo. This contained all detected body landmark. Example, at landmark number 0, we have nose. At landmark number 11, we have left shoulder. At landmark number 12, we have right shoulder. And each of the landmark contained x-axis, y-axis and visibility. We create that earlier, and then we run post mppost.post connection. This tell media pipe which landmark should be connected. For example, shoulder to elbow, 11 to 13, elbow to wrist, 13 to 15. Also hip to knee, 23 to 25, and knee to ankle, 25 to 27. Internally, it is a set of landmark pair, so we don't need to create it manually. After that, we define the landmark style using drawing specs, mpdrawing.drawing specs, and we set thickness 2, border thickness of landmark circle 2. Okay, then we define the circle radius and we set circle radius 3. And next, for the common style such as lines, here again I'm going to call mpdrawing.drawing specs, and inside the round braces, this time I'm going to set thickness equal to 2. That's it. Basically, here we style the lines thickness. We define the thickness of the skeleton lines and we set it to 2 pixel. So we are almost done. Now, outside this if condition, so I'm going to move out from this if condition, and here I'm going to display the window, the main window. Here we are going to show the result, and I'm going to type cv2 dot I'm show method, and our window name is pose landmarker, and I want to display the frame itself because we draw all the lines and landmarks in our frame. After that, I'm going to run the wait key method. So here I'm going to type cv2.waitKey. I'm going to wait for 1 millisecond, and I'm going to set if condition. If we press Q in our keyboard, then I want to break the loop. Otherwise, if you want to quit the program, if you press escape key, for that you can type 27, the escape key code. And then come the cleanup part. So outside the while loop, I'm going to release the capture. Also, I'm going to destroy all the windows, and I'm going to save this file. Now to save this file, let's run the code in our terminal and see is it work successfully or not. Is it detect our body pose or not? First we try with the light model, then we try with the full model. So let's save the file and run the code in our terminal. So let's hit the run button, and after hit the run button, we need to wait for some time to start the webcam. Now to wait for some time, as you can see, it open a window pose landmarker, and it already start tracking my body posture. You can notice the joints of elbow, shoulder, hip joint, and if I move my leg, also it create the skeleton on my leg. And if I move my hand any direction, you can notice skeleton move with that. Also it track my eyes, nose, mouth, eyebrows, etc. Here we test our program with light model. Now I'm going to kill the terminal and I'm going to rerun the code with full model. So after kill the terminal, I'm going to scroll up the page, and here I'm going to change the landmarker. I'm going to replace light with full, and then again I'm going to run the code in my terminal. It is a little bit slower, but it is quite accurate. Now after wait for some time, as you can see, it opened the window. Now if you compare with our previous model, you can notice our previous model is not able to track the lower portion of our body because it was fast but not accurate. But in full version, it accurately detect the joints and draw the landmark, also it draw the lines. At the same way, if you want to try the heavy version, yes, you can just replace with heavy. So this is it for this tutorial. I hope you enjoy this project. Thank you very much. See you soon. Hello guys, good to see you back. In that tutorial, we need to convert the program into a function similar to hand gesture program. But in that tutorial, we need to send up and down value. In our previous tutorial, in our hand gesture program, we create a function and we send left and right value. But in that tutorial, we need to particularly send up and down value. So with the head movement, we can control the drone up and down. As you can see in this example, here we split the screen horizontally. We split this screen into 3 parts: up zone, dead zone and bottom zone. So whenever I move my nose to the up zone, it gains altitude. And whenever I move my nose to the down zone, then our drone reduces the altitude. So this is what we are going to create in that tutorial. So without wasting your time, let's get started. So finally we are in my Visual Studio Code editor, and here I open my previous document body.py. This program can identify body structure, also draw the landmark and skeleton over it. But I don't want that. I want to target nose only. As you can see, nose is the center point of our head, and we need to target nose only to control the drone with our body. Basically, with the head movement, if we move our head upward, I mean landmark number 0 upward, then it going to gain altitude. Our drone going to gain altitude. And if we move our head downward, then our drone lose altitude. So we are going to control altitude with it. That's why I'm going to target landmark number 0 because it is in centered in our head. So let's back to the code. At first, I'm going to change the file name. I'm going to replace body.py with pose control, pose underscore control, pose control.py. Then I'm going to define dead zone. If you remember our previous mission, then you know what is dead zone. So at that section, I'm going to type dead zone 60 pixel. And then we define the pose line marker. Here we set the base option, and our object, pose line marker. So at that section, we don't need to change anything. Now let's come to the next part, drawing utilities. From here, I'm going to remove something. I don't need this drawing utilities anymore. So I remove that because I'm not going to draw the skeleton over our body. Just we need to draw a landmark in our nose at landmark number 0. Then we capture the webcam and define timestamp variable, and we jump into the while loop. But as you know, we need to convert this while loop into a function that's going to return up and down value. For that, I'm going to replace while true loop with a function, and our function name is getBodyRC. So here I'm going to type def getBodyRC. Also, we need to remove break statement because now we don't have any loop over here. We are going to run the loop in our main file. That's why we need to remove that, and here I'm going to return 0. Return 0. After that, we need to flip the frame. Also, we need to convert the frame into BGR to RGB. Then we need to create this image, MP image. So we don't need to change so much here, and let's jump into the drawing section. Here we draw the skeleton, but this time we don't need to draw any skeleton. Here we need to draw some rectangles to divide the screen into 3 parts. This time we need to divide the screen horizontally, not vertically. So I'm going to delete that portion. I don't need that. Also, I'm going to remove everything from this section, and after that, after incrementing the timestamp, I'm going to type a single line comment. I'm going to define it is draw zone. Then after that, I'm going to define the rectangles one by one. This is our first rectangle, and I draw the rectangle from the top to dead zone. This is our second rectangle. Basically, here I divide the screen into 3 parts with 3 rectangles. Now let's create the third rectangle. So here we type cv2.rectangle, and I want to create the rectangle in a frame. Then we define the position of our rectangle, and I draw the rectangle from dead zone to bottom of the screen. Next, we need to define the rectangle zone with text. For that, we need to use cv2.putText method. cv2.putText, and I want to put the text inside the frame, and our text is up. This is for up zone. Next, I'm going to define the text for dead zone, and after that, I'm going to define the area for down zone. So here I'm going to type down. After define the zone and divide the window area into 3 parts, we need to work on pose detection. But before, I'm going to define a value. I'm going to define a variable up and down. Up and down equal to 0. It initializes with 0. Then at the next section, I'm going to start pose detection. So here I'm going to type a single line comment, pose detection, and after that I'm going to set an if condition. So I'm going to type if result.pose landmark, it check whether a person was detected or not. If person is detected, Then we are going to jump into the if condition, and if person is not detected, it's going to skip the program. If person is detected, then inside the if condition, I want to get the first person. And as you know, here we allow number of pose equal to 1. So it's going to detect only one person at a time. To access it, we need to use its index number. So I'm going to type landmarks equal to result.pose landmarks. Inside the square braces, I pass 0 because we need to target the first person. If we allow 2% and both the person in front of webcam, then we can access second person also using index number. If we change the index number 0 to 1, then it's going to select the second person. But this time we allow only one person at a time, so we need to pass 0 here. Now, these landmarks contain 33 landmark points. You know that. And every landmark point contained x value, y value, and z value. But we need to target landmark number 0. First, we need to target landmark number 0 because we need to target the nose. So here I'm going to define a variable nose equal to landmarks. From landmarks, I want to target landmark number 0. So we target the nose successfully. Now, similar to hand landmark, we need to extract the x-axis point of the nose and y-axis point of the nose. For that, we need to create that calculation. So I'm type nose x equal to, here I use int function, and I type nose.x multiply width of this frame. At the same way, we need to extract the nose y-axis, and this time we need to multiply with height. Here I convert it into a normal pixel value. So we have x-axis and y-axis position of the nose. So we can easily draw this circle. To draw this circle, we need to use cv2.circle function. And here we draw the circle. And we fill the circle with this color, with blue color. Now after draw this circle, we need to detect the zone, such as up zone, down zone, and dead zone. For that, I type a single line comment zone detection, and here I'm going to type a if condition. If nose y less than the height divided by 2 minus dead zone, in that case, I'm going to define the zone equal to zone value. I'm going to set it up, and also I'm going to set up and down speed. Here I'm going to set up down speed value 30. It is up to you how fast you want to move your drone. I want to move the drone 30 cm per second, that's why I pass 30 here. After that, else if nose y greater than height divided by 2 plus dead zone, and at that section I'm going to define the zone down zone, and I'm going to set up and down value minus 30. We are going to use this up and down value in our RC control function. That's going to control the drone. Then else, in our else block, else I'm going to define the zone dead zone, and I'm going to set up and down value 0. That's it. Next, I want to print a label. I want to print a label at close to landmark number 0. I mean our nose. For that, here I'm going to use cv2.putText method, and I'm going to put the text inside the frame window, and here I'm going to set our text zone name. And from nose x-axis direction I add 10 pixel, and from nose y-axis direction I minus 10 pixel. I place the text at that position, and here I use white text. Then outside the if condition, here I'm going to display the frame. So I'm going to type cv2.imshow method inside the round braces. I set the window name body control, and I display the frame. Then we run wait key method, and you know the process, and after that I'm going to return the value. So here I'm going to type return up and down. I want to return the up and down value. This up and down value could be a minus 30, otherwise positive 30. And according to the value, you can move the drone up, otherwise down. Now, I'm going to remove all of these, and here I'm going to define another function. And our function name is close camera. So I'm going to type def close camera. And inside the function, I release the capture of the camera and also destroy all the windows which I created with OpenCV. And I'm going to save that file. This file is pretty similar with our previous tutorial file where we detect the hand landmark. In our previous tutorial, we target our hand wrist joint, but in that tutorial, here we target our body. From the body skeleton, we specially target our nose. So we create the necessary function. At the next part of this tutorial, we are going to create the main file where I'm going to call that function in a while loop and execute our program. So this is it for this tutorial. Stay tuned for the next part of this tutorial.